but they may need to be logged in, and I'm not sure if,
Oh, yes.
and like I tried, we're just gonna sign up again, because I think my corporate account doesn't work. Okay. Yeah, sure. I'll keep talking so that we can check the mic. No worries. Let's see if I actually did the smart thing and added it. Nope. Cool. Do we need, I mean, you can log into your account
I
too.
got into mine, yeah.
So, yeah, I don't know what my limits or quotas are, so.
Okay. Hello?
I'm Matt Craig, I'm one of the tutorial chairs.
Okay.
Oh,
Just
great.
wanted to ask you guys to, if you get questions, repeat them into the microphone because we're recording.
Okay.
And I'll poke my head in about 10 minutes, just in case there are any fires that need to be put out, just
Sounds
wait
good.
for scream or whatever.
Sounds good.
We're also, all of the chairs are monitoring the tutorial Slack channel, so if you have an issue and it gets posted in there, we should see it too.
Okay.
You all are ready to go?
Should be.
Okay.
Excellent.
I'll let you sign
Everything all good?
I think so, yeah.
Alrighty, so any questions, concerns, and or feedbacks before I start heading out again to check out with the other breakouts?
Not really, I think we're good.
Alright, so if you do have any problems or concerns, my business card is just on that table right behind you on the mix board, and we do have a wireless handheld right there, so I'll show you how to use that real quick. If you need this. That turns it on. But it is a 4-hour study. So yeah, batteries are right here. We'll fix that up. It's called ourselves, and hopefully right now, it's all good to go. We'll fix up any audience. Yeah. No worries, take care.
We're good, yep. Yeah, let's go ahead and just have them on the desks, I think.
Actually, I need to make that a power board.
They look like they're repeats, but
Counts, temporary counts. All the benefits, you guys are. Okay, you already have one, that's fine. Okay, I can use this. You've already got it. So you got it.
right, because unless you already have
Okay. This is just, we set up a tenant, so
this is.
if you get access to Copilot and all the other. Well, there'll be a second.
Yeah, so basically, if you have, either the desktop version, desktop version of 411 or.
I'm on the Excel.
Yeah, okay, well, that's.
Office,
Yeah, so is there any reason I would need to do that today, or can I just do it? Like, I'm gonna be sharing the files. Okay, like, really the main thing is, because I already have the, yeah, why did they do this? I have to use my free account instead of my paid. Yep. Alrighty.
All right, it's 1:30.
Yep. Be more or less on time, yep. Alrighty. Testing, do the captions come up? Yes, awesome. Cool, well, welcome everybody. I am excited to be at another SciPy and hang out with some cool people and talking about some cool tech stuff. In this case, the either beloved or hated spreadsheets. That sounded better in my head. I'm Dr. Sarah Kaiser. I am a developer advocate at Microsoft, and
Hi, and I'm Jim Kitchen. I'm a senior software engineer at Anaconda. So,
we'll together be
Yep.
bringing you through
Tag teaming
the,
this.
the full spreadsheet experience as it is right now. So today we have a lot of stuff to cover, but please, questions and interactions are definitely the most important. So please ask anything as we're going. You don't have to hold it till the end or anything. We'll talk a little bit about what is a spreadsheet, and then we're just going to jump straight into the Python and Excel stuff because it's the newest and also possibly the most exciting. But I did want to ask folks real quick, does everybody have either Excel downloaded or has used the login to get access to Python and Excel? Does anybody still need help with that? Okay, cool. Okay, cool. We can handle that while I'm doing some intro stuff. But yeah, so we'll talk about, Jim's here to also share more about kind of the advanced features of Python and Excel, as well as the Anaconda Toolbox and Anaconda Code. And then on the backside, we'll talk about doing spreadsheets from the other direction. So the direction that I originally was familiar with, which was you're in Python and you need to work with spreadsheets because they're too big to open. So hopefully you'll be able to walk away from today with these sorts of skills. I'm guessing a lot of folks have experience in these kind of different categories already, but hopefully you'll be able to add some new skills to your toolbox. And also my dog will be here with us in spirit because he really likes spreadsheets. I asked him. But anyway, so what is a spreadsheet actually? Who's worked with data that looks like this? I'm guessing probably all of you. How about like this? Okay, again, most of you. How about like this? Actually, nice. Yeah, when I was looking up some stuff about this, basically since many, like thousands of years BC, people were actually writing numbers in tables. This is actually an accounting ledger. So we are following in great footsteps here. But this is all tabular text formatted data. We've probably all used this sort of format, and it's good for storage, but it's not really interactable. It's kind of hard to actually work with. I mean, you have to involve a lot of other tools. So kind of spreadsheets were the natural evolution here. So it's something that allows you to not only store and represent that tabular data, but interact with it, importantly, in a real-time way. So the history of the different applications that we've had to manipulate spreadsheets has left an interesting fingerprint. Has anybody used any of the like Lotus 123 or VisiCalc? Nice. I was trying to spin up a VM that I could get those to run to show people, but I was unsuccessful. But anyway, really kind of in my mind, the spreadsheets really bring us to a place of an accessible data science tool. My first, I guess, data science project was organizing my rock collection in like Excel 95. So, and I could not pass up the relevant XKCD here, which is when people build full databases on top of spreadsheets and then you cry because it really should have just been a database. So Excel and spreadsheets are not always the right tool for your problem. Please think through that first. Because they do have some limitations. I think the biggest that I've run into is version controlling is really hard, especially if you're collaborating with a bunch of people. I don't know, maybe you put it in a Git repo and then, anyway, it's not the nicest format to work with from that standpoint, and depending on what formats you save it in, you can have some size limitations. So they're not perfect. They do come as a standard, there's a standard for the document format, which does include, like if you've seen these cell reference syntax before, this actually holds for all, should hold for any spreadsheet tools. Oops. Oh, I got rid of my, I had animations here to help. Anyway, yeah, so like B2, selects a single one, you can select a slice. The one that I always forget is if you use a $sign, you can pin part of a selection. So probably all the Excel whizzes here know this. But, and the thing I was mentioning earlier about how the history of the tools does impact, there was a very famous example of some genetic researchers that had a lot of their, I'm seeing some nodding heads. Yeah, basically they kept getting all their data turned into dates that were wrong. So basically, if you are working with dates in spreadsheets, just make sure you try to use ISO standards or just don't. Just because your tool is likely, especially if the date's before 1900, it's gonna mess it up. So, and one of the most, when I'm running into problems with my spreadsheet files, they're actually XML documents. So if you change the extension to a zip, like if you ever have any questions or you want to actually get to the data inside, you change it to a zip, you unzip it, and all the data's in there. So I actually had to do this a bunch when I was learning how to use OpenPyXL, because it will give you this whole raw structure and then you'll have to figure out how to navigate it. But anyway, so more of an FYI there. Okay, cool. Did we resolve all of the setup issues, questions? Cool beans. All right, well, let's actually get into this Chewy's ready with his laptop, and let's get into Python and Excel stuff. So I may have also been watching Severance recently, but macros are kind of synonymous with spreadsheets. They were basically a way you could write more advanced functions or script more parts of the spreadsheet that kind of went past the kind of equals function sort of functionality. And normally, one of the primary languages for that is VBA, which I don't think who here knows VBA? Nice. Okay, Jim. Also Jim. Yeah, I don't know VBA, so I am kind of out of luck if I want to write some macros. I'd have to either do what I normally do, which is just go straight to Python and edit the spreadsheet. And they're honestly a huge security risk. That's kind of one of the major reasons we don't use them anymore, because they can allow almost arbitrary code to run on your machine, which IT admins don't really like. But so if you don't want to learn VBA, let's try Python. So Python in Excel is a somewhat newish feature. It launched, I think, roughly about 2 years ago, but it's in public preview. Still in public preview because there's lots of categories here that are getting tested. So it's almost fully out at this point. It's available on all platforms, the web, Mac, Windows, everything there. But yeah, it basically allows you to run Python directly in your spreadsheet, kind of addressing a lot of the same pain points that like macros addressed before. And then you don't also have to have like a separate Python project. If you're working with somebody at work, you've got a data pipeline coming in, you don't have to have your Python version of the project and they're doing their own like plotting, it makes it a lot easier to collaborate. So how does it actually work? I'm just gonna click off, they went in the opposite order. Anyway, so you have cells in Excel that you can designate as these are Python code cells. Excel will take all of those and kind of transform it into a Jupyter notebook that then it sends to a remote kernel that's running Python, and it's actually running an Anaconda distro of Python with slight constraints for security. But yeah, then it runs the code, it comes back to your local Excel application, and like the data only goes those two places. It lives in your spreadsheet, and it gets executed in the cloud. So in my head, I kind of just think of them now as 2D Jupyter notebooks because you can turn any cell in a spreadsheet into a Python cell. So kind of pros and cons here of this sort of approach. It's really great for, one of the design goals here for the feature was security. So an obvious question is, well, why doesn't it run Python locally on my machine? Well, I don't know what's on your machine. I don't know if your machine is compromised. I don't know how to find Python distros. I don't know if it has the right packages installed. So by having it run in a security vetted container in the cloud, it honestly kind of kills two birds with one stone. You don't have to set up Python on a person's machine. And then the data, there is much less risk of the data being exfiltrated. The kind of limitations that come with that is that container, for security purposes, doesn't have network access. So you can't pip install new packages there. You can't download data sets from Python in that container. You can certainly get data sets in through lots of functionalities in Excel, and we'll talk about that. But basically, think of it as just, it can run your code and that's it. And it's pre-set up, like you don't have much control over what that image is, at least at the moment. Yeah, I think that's most there. So let's just actually look at doing this here. So, and this notebook that I'm using right here is in the repo, so don't worry about, like, you can follow along as I go. You can also just download it and follow it later. But let's actually, okay. I have the one problem here with presenting Excel is I can only scale the cells. So, alrighty, I want to actually add a Python cell. So you'll notice here that in my, if this is my normal bar, if I go to formulas here, this, can everybody see that? Or should I, can I do screen zoom? Oh, magnifier, is that what it's called? There we go. Oh, now it's like my mouse moves at 8 pixels a second. Anyway, I think we'll have to, that's not really working. Anyway, that section up there where you see the tiny blue Python, there's a zoomed version of it in the sheet. Okay, there we go. That's what it looks like. And you can see it kind of has 4-ish buttons here. So if I had a cell here and I wanted to turn it into a Python cell, one option is I could hit this button. Now you can see it has this kind of green PY tag to the side of the cell. It also has this label up in the formula bar now as well that kind of distinguishes it from, say, just a normal cell. The other way I can do it is I can type equals capital P, capital Y, and then open parentheses. That basically does the same thing. When I push the insert Python button, you can also see it pops up a helpful sidebar with some samples, sorts of things, which we'll use later in the tutorial. So we see the badge. So the other thing that you might reasonably have a question about is Python can return a lot of different types. Like you can return objects, you can return anything defined in your packages. Excel doesn't necessarily know about all of those things. So when you have a, I'm going to make this a Python cell. I'm going to type 1 + 1. Oh, I'm not going to type 1 + 1. That's going to give us an error. I hit Control-Enter to actually run it. And now you can see it's showing me the result here with, again, a kind of a Python badge here to remind us that this result came from the Python runtime. But you'll see that there is a, hopefully you can see it just to the left of our formula bar here, is the Python. There's basically a way for you to toggle the output of the, basically when the Python function sends you the result back, Excel's gonna try and guess at the right way to interpret it. So for most things like ints, floats, booleans, like those are no problem. It's more so when like it returns an object. It knows Pandas data frame stuff. So like Pandas is pretty well handled, but if you have another package that returns an object, it will give it back to you and you can keep working with it, but it's not gonna be easy for it to render an example, render the output. You can, since when you're working with this, if I have this cell here that has the 2 in it, and then I maybe make another Excel function where I can say just equals sum, and I can do the thing where I click here and it automatically writes it in. That is the most boring function. But you'll see that the Excel functions work perfectly well with Python output and vice versa. So that's kind of, if you have a situation where Excel functions aren't properly understanding the Python object, you can change, that's where basically doing this toggle here to say, I want a Python object or I want an Excel value. Excel is just collapse it down to the dumbest option or the simplest option so that other things can understand it. And you can, this is one place you can do it. You can also, I think, right-click on the cell to, yeah, Python output. So, cell references work just the same way as they do in Excel. So like if I have this code cell here that has, you'll see a lot of different places this Excel function. That does only live in the Python and Excel. You can't, that's not a package you can load or use anywhere else. It's basically the helper that connects the data in your Excel spreadsheet to the kind of Python kernel side. So you can see here, this Excel function, it's very simple. It only takes slices and whether there's headers. So like there's just this one function. So if you basically need to pass some data into that kernel, you can either manually write Excel or there are lots of tools that will help you do this, but you just give the slice, table name, query name for Power Query, however Excel knows how to reference that data. So you can see here, that's just a slice. You can do it, yeah, to like pre-made tables as well, because I think that that's not doing it right. Anyway, calculation order. I did say that this is a two-dimensional Jupyter notebook. Generally, just for my own sanity, I keep everything in one column, just so that I know what order it's executing in. But it does go left to right, top to bottom. So you could hypothetically put cells all over your notebook, and it does do a good job, like it would for Excel functions, of knowing like the dependency order for those, but it will run them in the Python kernel right to left, top to bottom. So, and as I found out recently, if the language pack you're using reads right to left, it actually executes them right to left. So I don't know if that impacts anyone here. Huh?
That's new.
I know, I was like, wow, that's surprisingly considerate, but also now I feel like that is confusing. Anyway, so let's see. Errors obviously happen. So like if you had an error in a Jupyter notebook, then you would have, usually it prints out the message. Here it's potentially not, you're gonna see something that looks like this, #Python. So I'm gonna just make an error. We'll do that 1 plus that I did earlier. So that's obviously not something that's well defined in Python. If I look at it, I get this, I can make this bigger though, actually. That's good. But of course, this doesn't get any bigger. You can see there's a little warning sign here. It gives you a bunch of options for how you can see the error message. This is kind of what would pop up in your, like the output of the cell. Possibly the more helpful option is if you click to the up in our toolbar, you go for the editor. What you'll find, and I mostly use this, most of the time, you have basically a Jupyter Notebook viewer for all the cells. So I could here, so this is F5, current, you can filter based on what sheet, and if you have like a bunch of sheets like this. So there you can see this is a much more kind of familiar scenario. It's a Jupyter Notebook cell giving me the output results. So there's, I think that makes sense. And you can, there are also things to, you can ask Copilot to help resolve the error if it's not clear to you what the issue is. We said earlier that this container runs a version of Anaconda, the Anaconda distro. Jim can probably say a lot more about this, but it's basically, it's a reduced, like if I were to just go to anaconda.org and download stuff, it's pretty close to that, but with a number of packages cut for kind of security vetting purposes. So basically Microsoft is partnering with Anaconda on this to make sure that there's a full kind of chain of custody and all the bill of material, software bill of material, SBOM stuff, all of the security people are happy. So there is a number of packages though. So another fun place to kind of investigate up here in your toolbar is the initialization button. I'll try and make this bigger. But basically, whenever that remote kernel starts up, it runs kind of a set of startup instructions here. So it basically imports the most common libraries and sets a couple conversion things to make it easier to convert data for Excel. This right now is not editable, but actually coming to Excel soon near you, this will be editable. I've been trying out actually the betas for this. So I find that really exciting because then, like, say if I have functions for like how my company likes to visualize our forecasts or something like that, I can just bake those into this initialization. And then anyone I'm working with on this workbook can just use that function or use like variables or things that I've defined in there without me having to remind them or without anyone having to think about it. It's just run every time, all the time. Let's see. So obviously one of the people's favorite things to do with Python is to make visualizations, and that's kind of one of the reasons why like Excel can make plots. They're okay. But you're never going to find as much variety or kind of the customization options, or in my mind, the easiness of customization as you will with Python. So now you can just directly use Python to do your plots in Excel. So here we see an example of, so there's just some example data here. If I look at, this is kind of a common paradigm that I see with how folks are using this. But basically, if you're kind of writing a couple code cells here, because there isn't like necessarily a nice output, like when you load libraries, normally it just, nothing happens, right? You don't see anything. People like to see something in that cell. So you can, at the end of any Python cell, put these, it's just a string, which obviously that wouldn't be valid in Python. But here, basically you can think of it as like a comment that will display in the cell after it's done running. So here, we're importing a bunch of libraries, and then just a little message, libraries loaded, so that when I look at this cell, I kind of know what's happening there, just because, I mean, that's short enough I can expand this, but like when I start getting to like the actual, oops. Okay, those are kind of short. H3. Yeah, anyway, like obviously the code, you want to see more than like 3 or 4 lines of code at once. So that's also, again, why I would normally look at the editor view over here. But you can make any sort of static image plots. There isn't really any way at the moment to have like, it doesn't have Plotly, but there are interactive elements you can create with Matplotlib and Seaborn. At the moment, it's just a static image, just because that's what spreadsheets can support. They don't necessarily have a concept of a interactive thing, but something as another fun thing to look forward to. There are ways that we're looking at trying to have an interactive panel on the side so that you could actually have those interactive like plot dashboards and stuff in your spreadsheet. We looked at the Python editor, and I think, yeah, I've got a number of useful shortcuts here. Really the one thing that I always have to remember is in Jupyter Notebooks, it's Shift-Enter. Here it's Control-Enter, just because Shift-Enter already had a very established Excel understanding. So otherwise, pretty much everything else maps over in a nice way. But yeah, is there any initial questions or comments or observations? Yeah, go for it.
You mentioned a repo. Where is it?
Oh, that would be a good one. It's just, I think I have it. It's aka.ms/scipy-sheets. Sorry, that should have been on the slide before this. But everything I have here, including the slides, including all the sample documents and stuff. So we'll get back to that. Any other questions? Has anybody tried this out before, actually? No one ever tried it. Okay, go for it.
So can you talk again about where the kernel lies
Mm-hmm.
in the environment and what control you have over that
Yeah, so,
Repeat the question.
oh yeah, I need to repeat the question. The question was, can you speak more about kind of the infrastructure and configurability of the remote execution container? Does that seem fair? Yeah, so it's, I mean, basically, I think it's a Kubernetes, basically, it's pre-made. There really isn't much at the moment you can customize about it. Really, it's kind of locked down mostly for security purposes, so like they lock all the versions of everything. That said, one of the obviously major feedback things and kind of interesting, you can see a lot of these sorts of discussions and feature ideas. There's a GitHub repo, actually, where people are making these comments and stuff to the dev team. But I think there is kind of ideas around, like, say you're an enterprise customer or something like that, and you have your own container registry or whatever, you can say, we would like our container, and then you can have everything pre-set up there with your internal packages installed and things like that. So far, that's not really not been something that has had a lot of focus, just because it's been an interesting process, like watching this whole dev team working on this, because you have 3 very opinionated groups that you're trying to make happy. You're trying to make the Excel Pro power users happy, who know exactly how they want their Excel to work. You have the Pythonistas that know how they like to work. And that partly was the feedback from Pythonistas that got the Python editor added. You were just gonna have to edit Python in 5-line chunks up in the top. So, there's the Pythonistas, and then there's also the security people. So I think it's kind of been a longer journey to try and, find where the middle is for all of that. But honestly, I'm pretty excited about where we're getting to. That does mean that there are some compromises, like no internet access in the container, and it's not easy or not possible at the moment to customize that. But I do think those are kind of, once things are settled on the current iteration, those are definitely the next steps for those plans. Yeah. I'll go back to my stuff here. This is just kind of a summary of the whole Python and Excel kind of feature thing. It gives you remote execution, trusted packaging. Your devices are secure because that Python kernel does not have access to anything on your machine. So it is only what is in, you can't open a file from your desktop with that, unless you've already used Excel to open it. And it's pretty easy to collaborate. So in the same way that you can share a link to your Word doc or Google Doc, you can share a link to these Excel spreadsheets, and you can actually co-write code, Python code, and run Python code together in the spreadsheet. Some of the examples that I showed you there, there's if you want to share this with other folks that have the feature, in just the home panel, there's a nice tutorial that folks can walk through. So that kind of brings us to our first exercise here. Hopefully did everybody find the repo on GitHub? Cool. In the repo, there is this Python and Excel, which is the sheets that we were just looking at. And at the very end, there's one called the library index. So I made that so that it actually just lists out every package, what is that entire environment that you're looking at. I'll show you what that looks like. Let's make this bigger. So just because it was kind of hard to see all this in the actual docs, this is a list of all the packages that are in this environment. Some some are obvious, like pandas and NumPy. So your exercise here is to pick something that isn't one of the core packages, so those are highlighted in green here: NumPy, pandas, Seaborn, stats models. So pick another one and see if you can make write a code sample in your Excel spreadsheet using that package. So you can literally just go to that package's documentation. So like if I go here, I've got links to all of their docs. So if I wanted to go, one of my favorites is Faker. If I go to the homepage for Faker, I can probably find some code samples here that if I copy and paste those into a cell in Excel, those should work just fine. So I do like this. I can make like a new sheet. I say, hello, this is a Python cell. Paste. Control Enter. You can see it's showing me busy. Basically what that means is usually it's very quick, but the busy is just it hasn't connected to the remote kernel yet. But once it does, then yeah, you can see it gave me a fake name. So pick maybe there's a package in that list you're already familiar with. Maybe there's a new one you want to try out. I'll give you about 10-ish, 5 to 10 minutes on that. And yeah, please ask if you have any questions.
Instructions for it, but category doesn't exist on here.
Yeah, folks coming. Cool. Someone asked a good question while we were walking around that I wanted to point out something that is a common, that can be confusing and confused me also for a while. So I use Faker here to make a larger table of names and addresses. So there's 30 of them in there. And I turned it into a data frame. So in our code editor view of the world, it looks just like we would the output from a cell. It shows me the preview of the data frame. I can, let me just delete this. If I'm looking at something where like the output is an object, it's a data frame, you've got a couple little badges that pop up here. The one that kind of looks like a table allows you to inspect basically attribute fields of that object. So for data frames, one of them is you can look at a preview of it. So, and sometimes, like especially if you're asking Copilot questions about stuff, it'll show you these array previews. This data doesn't necessarily live in these cells. Think of it as like it's an illusion. Because you can see that there are these ... dots. Like I made this big enough so that it's not actually, it's showing you the head and tail of what that data is, and that's why it's a preview. If you wanted to work with this data, and now go back to Excel, I just named that data frame data. I can just literally type that in a new Python cell, and I change the output type to Excel value. So that says make the output Excel valued. I hit Control Enter. Now all of the data is here. It is and these are cells that you could reliably then refer to with other functions and stuff like that. So it's maybe a better example / motivation for why you need kind of the Python output or Excel output. Because if I wanted to keep working in Python and working with the data frame, it's totally fine to leave it as that. You don't have to cast it to Excel and go back and forth and back and forth. Anyway, out of curiosity, what packages did folks pick? Sci-fi? Okay. There's no right answer. Fair enough. Cool. Well, I think that brings us to not that section. now to Jim.
Oh, okay.
Yeah, because it's your advanced stuff, and then I talk about. It's unfortunate that the advanced analysis is the name of the next one.
Yeah. Okay. So out of curiosity, before you guys came, did anyone use Python in Excel? No? Okay. Then this next section will likely go over your head. But that's fine. This is, once you become experts at your work, then everyone will love this. Let's see. Where's the repo? Or do you already have the slides open, the Jupyter book? All right. All right, I'm going to see if we can split screen here. That's okay. Computers are hard. So. And screen real estate is precious. All right, so we'll try to get these up tight, and we'll go ahead and make a new workbook. All right, so feel free to work along if you want. That's what this is designed to just start with the blank workbook, and we're going to build something together and show you some advanced features of Python and Excel. Okay, there's a Python Excel review. I think we've already covered that, so I think we'll just skip that. All right, let's talk about the built-in repers that Python and Excel has. So Python and Excel has sort of, if you're mapping from Python objects back into what Excel natively has, there's 4 standard things it can represent. It knows about lists and 1D arrays. It knows about 2-dimensional things, lists of lists. Data frames would fall into that category, NumPy arrays. It knows about dictionaries, and it knows about static images. So as long as your Python cell returns one of those things, it's going to look very nice in Excel. If it's outside of those realms, then you just sort of get a generic, like, something. So let's look at some of these. So let's make a Python cell in here, and we're just going to make a list, 13579, run that. All right, and so we've got a list, and when you click on the little PY, we get a nice list that just says it's a 5x1 list, and you see those. So that's what I call a list view. Oh. Oh, the cards don't zoom. That's unfortunate.
Yeah, the cards don't, but you can pinch to zoom
On the,
You were doing it, I think, with the keyboard.
is there, I don't think there's a way to zoom this card, is there? Okay, all right, so you'll just have to see. All right, if we go to D10, we'll just make a list of lists, so. Typing is hard. All right, now this also looks like a list, but when you click on it, now we've got a 2-dimensional list. The data frames you saw earlier would have a header on them. So we've got list views, array views. If we go into G10, let's make another Python cell. And this time I'm just going to copy, paste this in so I can save. All right, so this is just a simple dictionary. But now we've actually got, it's sort of everything listed out. Notice that the list and data frame, just say it's a list and data frame. It doesn't give you the details out of that. Even though it's referencing these other lists that we made. And then what you can actually do with these is I can refer to this and do dot, and these dictionary attributes come up. So now I've got cherry comes out with pie, which was our dictionary here. So that's one nice thing about these dictionary views is that you can actually reach into them. Sort of think of it like a class that's now being exposed within Excel that you can't call functions on it, but at least there's like multiple attributes that you can get back. So I find dictionaries are actually a very useful way to return things from Python cells. If ever you need to have like a multi-return, return as a dictionary, give each one a name, and then you can actually like refer to it in different cells. Okay, I was talking though about how for like A here, it just says it's a list. And if I try to refer to it, it still just says list, which isn't very helpful. If I change the output type from a Python object to an Excel value, then I'll actually get the list. So normally this is the way that on a normal object, if I switch to an Excel value, that changes it to spill to the grid, whereas the default, just leaving it as a Python object, like collapses it to just sort of a representation that shows you it, and you can refer to it in other Python cells, but like Excel cells can't reach in. I can't just do like equals sum of this. Like that's not going to work because Excel doesn't have access to that Python variable. I'd have to spill it to the grid. With a dictionary, if you spill it, you make it one of these Excel value, then the attributes inside do get fully populated out. So you can actually like nest, lists and items And then you can actually like drill down into this, I call this a card view, and see what they're all about. But then also if you use the dot attribute, it spills itself. So by returning a dictionary and, returning it as Excel value, you can then play with those things and refer to it. And this actually lets you get outside of the row major order. So I can actually like move this up to the left and it'll still work. Because once it's in this form returned from Python, it's now fully in the Excel world. Like these dot attributes are sort of like, Excel knows about them. So when I do this dot A, it doesn't make another Python call. It just reaches and grabs it out of that. What's the technical term for this in Excel? A data entity card or something like that. If you go to the data tab, there's stocks and organizations. It's something Excel's been building, and I think Python and Excel is the first thing that really fleshed it out and made it really useful. Okay. All right, and we already looked at images, so we'll skip that. All right, so let's talk about now custom reppers. So I'm just going to get a new sheet here, rename it as custom reppers. All right, so the question is, what if you want to return something that's not one of the built-in types? So let's start in cell D1, and we're going to make a new Python cell. And first of all, how many of you have ever used complex numbers in Python? A few. Okay, it's built in. A lot of people don't know about it. I think they're pretty cool. So we're going to, 25 plus 42j, that's how you do it. You make a complex number, and it will come back and say, hey, this is complex. And if we look at the representation, it just says, yeah, that's its Python string, that's its type and a type name. But basically, Excel's throwing up its hand that's like, I don't have a good representation for complex numbers. So I'll kind of just give you like Python strings, but that's it. And if we try to convert that to an Excel value, we'll actually get an error that just says NA, and if we mouse over, it says the Python object doesn't have an Excel representation defined. Sorry, I need to zoom in again, don't I? Not that will really help. So Excel doesn't know how to deal with complex numbers. Even though we know there's a nice real and imaginary part, it would be great if we could do that. So if we wanted that to spill out to the grid to sort of like pick out the real and imaginary part because we had done some complex calculation, one option is we could just manually convert it to one of those built-in types. So I could just say c.real, c.imag, put it in my, c.imag, put that in one of my own lists, and now it'll spill out. Cool, but that means that every calculation at the end of the cell, I basically have to like manually tell Excel how to deal with it, which is annoying. So we have a way that we can associate a type with a repper. So let's go into that. First, I'm going to get rid of this because I don't like that. Okay, so we're going to go to cell A1, make another Python cell. Normally, this we mentioned this like where is it? The initialization section of Python. Where'd that go? Anyways, there's the initialization section that's read-only right now. Normally, this is where we'd put it, but until then, we'll just put it in cell A1 so that it's available to everything else. So I'm again going to copy this, paste it, and then we'll look at it for a second. Yeah, let's try that. Where did my Python and Excel go? No, it just disappeared. Uh-oh. Is there a shortcut to get the editor? Maybe.
If you search in the bar at the top.
Okay. Okay, well, I guess it blows it up here. Okay, so what we do, we're defining a function that takes C, and we're gonna just return, again, a known object that it knows. So we're gonna do a list of lists, so it'll actually spill, instead of down, it'll spill wide. And then there's already a built-in Excel library, Python library that runs up in the container. And we have excel.repr, and then we can register repr Excel value. We put in the type we want and then the function. So by doing that, it basically Excel will look and say, okay, every time I get a complex that you want to convert to an Excel value, and I don't know how to deal with it, I'll look in here, it's registered, I'll call this function, and that'll work. So as a result, when I return my complex item, now it spilled it for us. So I'm, again, I'm just returning the raw complex object, but it now spills to the grid because we registered it. Okay, let's go and change this back now to the Python object. So this Python object is still nothing. So these two different output types, the Python object and the Excel value, have two different things you have to register. So let's go ahead and add that. So we're going to copy this code in here. So we've already registered the value, and paste this code in. So now we've got the complex preview repr. So one's called the value and one's the preview. And if you look, we're registering the repr Excel preview instead of the value. And so this function will get called whenever it's that sort of card view. And here we're going to return a dictionary with the real and the imaginary part. Okay, so I run that, and now I've got a dictionary that now has real and imaginary pieces that I can then, pick out the same way as I was showing before. We can get the real portion, get the imaginary portion. So two different things you have to register, one depending on whether it's, someone's returning the Python object or the Excel value, but then you still just return one of the built-in things that Excel knows how to handle. You do that once, and then you could use these all throughout your spreadsheet, and now Excel knows about complex values. All right, questions on that? Okay. Okay, just to recap that we've got the two functions, one the value, the preview. Important to note that when you're registering, you're actually putting the Python type, not a string. So just something to be aware of. All right, an alternate method, if you're making your own class, which if you get fancy enough, you will do that, you can actually register it a lot easier with a built-in function. So let's go to A2, add another cell here. Okay, so I've got a point class that I've defined, just takes an x and y, calculates a distance, and now I define this underscore repr Excel value underscore, and I return an object. So whenever Excel sees a class that, it doesn't know what to do with, it's going to check to see if that class has this special method name, and if so, it'll call that. The same thing would be, repr Excel preview for the other style. So if we make this point class, then we can make a point in cell A5. So py, and now that I've defined a point, I can use it. And again, this first type, we didn't register anything, so this is just sort of the standard ugly way of dealing with it. But if I convert to an Excel value, now it comes out as this, two-dimensional, this list of lists with a string x and then the x value and a y and the y value. So I got a string x and then x and y and y. So you can deal with it however you want. And again, this is just now a point class, and I didn't have to explicitly register it, but by just having that special function, then Excel knows about it. Okay. Questions? Okay, because now we're going to get really crazy. Okay, so we've talked about just in all of these functions where we define our own thing, we're just returning a built-in object that Python already knows about. However, there is this fun thing that this is deep in the JavaScript Office add-ins documentation that explains these entity cards, and you can get pretty crazy with it. You can have return types that once you click on the button has like a sort of a hero image, a title, lots of different attributes, subsections. So there's all this detail that we can go into. But the important thing is it's just this block of JavaScript or like a JSON object that you have to return. And luckily JSON and Python basically have a really nice one-for-one mapping. And so we fortunately can, oh man, there's too many tabs in here. We're gonna go back. Okay, if we return a carefully formatted dictionary, then Excel will magically make one of these entity cards for us. So let's go back to A1 here. And we're gonna replace the complex preview, which we were just returning a dictionary before. And we're gonna put it here. All right, you guys aren't gonna be able to see that, are you? Okay, that's better. Okay, so now our function, it's still returning a dictionary, but it's returning a very special dictionary that has a key of type with a string entity. It's got to be exactly that way. It has a text field, and then it has some properties, which also is a dictionary. If you return something that looks exactly like this, then when you register it, now our complex object, well, first of all, you notice it says complex here instead of dict, like it said before. And we've got a title, which was the F string that we made, and we can have the same properties, the real and imaginary. So now, and the dot attributes still work before, but now we basically can define what we want it to say. And again, this was, because this text here, this is this F string, so that's what's going to be written out there as the small value, and then the properties are listed in there. Okay, so the things you got to have, I mentioned it's got to have type equals entity, and then a text field and some properties. One question you might have is why imaginary comes before real, and in here they just sort everything alphabetically. I mean, that's a reasonable choice. But we can actually customize that. So we're going to go back into our thing here, and now we're going to add this layout section. This is the new piece. And again, this seems magic, but there's documentation about it. Okay, so we've got card, and then a section, and then layout is list. These are just sort of boilerplate, but then the properties, we can now, it's a list. So now we can actually specify the order that we want them to show up. We want real to come first, and then imaginary. So we run that, and now we've actually got, it comes in real and imaginary, the order that we expected. Again, that's more just to make it look pretty. You could always access them however you want. Okay, now a complex number, all right, that's cool, but we can actually start building and adding a lot of interesting things. So now let's go ahead, we want to add a vector, so you can get the real and imaginary as just like a Python tuple that comes out. Maybe we want polar coordinates, so we're gonna have an R and a theta, and we can calculate all this, send it back to Excel, and then the user can grab these different attributes. So we're gonna come back in here. We're gonna import math, get that going. And then, let me blow this up if we can. All right, we're gonna add some new properties, which this is still all in Python land, so we can just write whatever Python code we want. So here I'm saying, as part of the properties I send back, I want a property called vector, and I just want it to be a tuple of the real and imaginary. R, you could take the absolute value of a complex number, you'll get the length of it, and then theta, this is where I needed math, we're going to do arctan of the imaginary over real to get, the theta value. And then in our, okay, the zoom is not helpful. All right, then the last thing we need to do is add another section to our layout. And now with this, we could put the vector, the r, and the theta in that section. Okay, with all of that, now we've got the different sections are sort of just have a horizontal rule beside them, or, breaking them apart. But now we've got the vector, and we've got r and theta calculated, that again, I can, just grab access in Excel. I can grab, dot theta, grab that, or d1 dot vector, and it'll spill out. So now you're like, okay, now it feels like, okay, we've actually turned a complex object into something real. So if you wanted to build a fancy, financial modeling thing and you want to return a model object, it could suddenly have start dates, end dates, length, some metrics around it. You could actually have the data returned as a list. And then, anyone who's coming from Excel can just use that, right? Like, they're like, do I need to learn Python? The answer is no. You could just sort of like send them the file, and they could then go and keep going by picking out these attributes from your model object. So, pretty handy. But kind of weird that you're just returning a carefully crafted dictionary, and then Excel notices that and magically converts it for you into this entity type. One other thing. So normally Python cells are, they're a totally separate thing. You can't mix and match Excel formulas. But with these attributes, if I say d1.vector, normally it's spilling vertically, but this is just regular Excel. So I can just use like the transpose function in Excel, and it'll flip it for me. Or I could do, the sum of d1.vector, right? It's just a list. And so you can actually mix and match these objects nicely in other ways. So, it's just an advanced way to use Python to sort of return an object, and then the Excel geeks will love you because then they can use their standard formulas and VLOOKUPs and everything else they know and love. All right, questions? Yes?
You showed in the JavaScript card preview that you put images.
Yes.
Have you been able to put images, like, can it just fetch web images, or does the image have to be in the spreadsheet?
That I don't know. I've only played with it in the spreadsheet.
It only just now occurred to me. I'm not trying
Yeah, no, I think you can maybe fetch stuff from the web, because again, the card view is actually rendered inside of Excel. It's not rendered, like Python's just returning a dictionary. Excel sees it as a very special formatted dictionary and then renders it. So I think, yeah, you could probably put a URL and fetch images like that.
So Chip, you're still limited to just what that environment provides, right? If I have a package that provides some functionality and I want to use that, I'm not able to.
Yeah, so the question is, you're still limited, are you still limited to what's in the Anaconda container that's running up on Azure? And the answer is yes, for now.
Seems very powerful, but much more powerful.
Yes. Well, I'll show you in another section. That's why we've got the Anaconda Toolbox. There's sort of an alternate approach I'll show you. But yeah, for now, it's a known limitation that lots of people want to install packages and customize that container. Right now, you can't. Okay, one last fun thing is that there are icons. So, everything I've done so far was just customizing the sort of the Python object view, but the Excel value can also be customized with this same entity card. Right now, I'm spilling it as just a list of lists, but I'm going to grab this. We're going to go in. Come on. All right. And we're going to tweak this. Oh, sorry. No, this is the point. Yeah. Okay, the point class I'm going to update. All right, let's grab this. We're going to change this. Okay, so this is the repr_xl value, but now we're returning one of these entity cards. And the only difference is that in the layouts, there's another section called compact with an icon that we've listed as data scatter. When I run that, now this point class actually has a custom icon here. In the repo, there's a file called icons.xlsx that just shows you like a whole list of built-in icons and the name that you have to use, this data scatter. Like, it's not like I put anything. There's a fixed number, but Excel's made a bunch of fun ones. So this is still the thing you click on to see the card, but now if you want to have airplanes and cats walking across your screen, like there's interesting things. So it just makes your things stand out a little bit more. Okay, let's get your hands dirty. So, all right, we saw that the built-in dictionary, if I just have A1, it just says dict, and then you get to see, A1. Okay, that's nice. I want you guys, we're going to see how, maybe we'll take, what's our time check? Could do like 10 minutes? Okay, 10 minutes. Try making a result class. So you can use the point class as a reference. It's going to take 3 items, sort of a D, which is a dictionary, and then a name and an icon. You're going to add the underscore repr_xl value and try to return one of these card views that takes the data and then uses the name as the text field and puts the icon in so that you could return a result that you want. And then you can have the repr_xl preview just call that repr_xl value, and then we can see the result. So take 10 minutes, I'll build it myself here, and then we'll see what we all did. That's what it looks like you do it wrong. Yay. That's how you get the editor comp, you just make an error. How do I zoom this on the right? Is there a good way to zoom the editor? Oh, just that, okay. Yeah. Okay, that works. All right, how long's it been? People still working? Okay, I could show my, let's see. Okay, here's my result class. All right, so we've got a result. Initialize it with the data, a name, and an icon, which there's one called generic that's useful if you don't specify one. Save those. RepRXL preview is just going to call RepRXL value. And RepRXL value, we've got type entity. The text is the name that you passed in. That's what they wanted to be displayed. The properties conveniently is a dictionary. So you just pass a dictionary to your result, and we can use those as the properties. In the layouts, that's where we specify the icon. And then to get a little fancier, we can specify that we want the properties to specifically be the list of self.d.keys, so it's in the order that Python has it, which Python dictionaries preserve order now since 3.7, so that's kind of a nice thing. Okay, and so with that, then we get, I could just define a dictionary and then wrap it as a result with the text my result and a plain icon, and now we get a nice, well, I should say, this is something to know. If it's in a Python object, it always has this bracket py. There's no way around that. But if we turn it to an Excel value, then the icon does come through. We get a nice airplane, and it still, it has properties of A1. Okay. Any questions? More than you ever wanted to know about output reppers? And by the way, this is actually not very well documented anywhere, so you guys are now the elite ninjas of the world. Go and spread the word. All right, time check. Do we want to talk about Excel? We good?
Yeah, I'd say we should probably go
Okay. All right, let me finish up here then. We'll try to be fast. Okay, we're going to make a new tab, call it All right, this one's going to be data conversion. All right, and so we talked about how things come out on the outside. So when a Python returns to Excel, we can deal with that. But there's also the things going the other way, which is when you're writing the Python code, Excel has to send the data up to the Python kernel, and that's what the Excel function is. So let's take a look at some of these. So we're going to come in here, and in cell B5, I'm going to do a little paste special and paste this as text. All right, so we got these different, these are just Excel objects. We got a Boolean, a string, some numbers, dates, whatever. And then in C5, we're going to have a Python cell, and we're just going to say, let me just copy it. So we're going to use the Excel function to get that value, and then just there we go. All right, we're going to get the type. And then I'm going to drag these down, which don't ever do this. Like, it's very much an anti-pattern to like drag Python formulas. Instead, write one formula and spill the result. But in this case, because I need to like grab the Excel of each one, so when you use the Excel function, if you grab a range, it always becomes a pandas data frame. Always. If you grab a single cell, then it tries to interpret it intelligently. And so we can see it actually is quite intelligent. It knows it can grab a Boolean, it knows a string, it actually knows the difference between int and float, even though Excel stores everything as floating point. It has date time, and then actually knows that this is a time. So the Excel function for a single box is actually very intelligent. It'll grab the nice thing. However, when you're using a range, as I said, it always turns into a pandas data frame. So let me, all right. So if you guys didn't know, you can do this in Excel with the curly braces and commas and semicolons. You can just write that out. So that is Excel. Okay, and if we're going to go to I5, all right, and I'm just going to drag here, and of course it'll fill in the F5 hash and the header is true for me, and it's going to be a data frame, right? It'll look nice, and this, a lot of times this is what you want. Sometimes though, it's not what you want. So let's just grab these guys here. All right, notice it didn't put the header true, so there's a lot of nice features built in. Let's go and control how that range function gets turned into Python objects. So we, of course, can control this. So I'm going to copy this code and all right, let's see if we can zoom in. Okay, so I write a custom conversion function. It's going to take an object and then has headers is false and then some keyword arguments. This should look familiar from just the Excel function where you can have headers is true. One thing to note is when we're writing this function, object is always a list of lists. So when you're grabbing like a range, Excel is always going to leave it as a list of lists. So we could just pass that into NumPy and make a NumPy array. Then we're going to call excel.setExcelArrayConversion. If you remember the initialization box that's read-only, it's got this same line in there. We're overwriting that. So we're just going to pass in our custom conversion for the Excel array conversion. There is a separate setExcel scalar conversion. We're just going to mess with the arrays today. So with that, now you see that here these suddenly became ND arrays. So just by calling the Excel function, we now have NumPy arrays instead of pandas data frame. Maybe that's what you want, is everything to become a NumPy array, but let's be more useful. All right, so I'm just going to come in here and just paste all this stuff, and we'll talk about it. Okay, so what did I do here? Okay, so I added a new keyword argument, type, and it defaults to data frame. And then I'm just going to have a big if-elif branch that just says if type is in none, or the string data frame pandas, PD, like whatever you want to call it, then I'm actually calling this convert to data frame, which is the built-in like convert to data frame method. Otherwise, if type is an ND array, NumPy, NP array, then we're going to return an NP array and explicitly make it so you can't set headers, because headers don't really make sense in a NumPy array. We can also have them pass in dictionary, and then we can do some fancy, dictionary comprehension to have like a 2-column, basically like a VLOOKUP, keys in the left first column, values in the right column. We can return that. You can tell me I want a list, and I'll try to figure out intelligently, did you mean like a row-wise list or a column-wise list, and we'll pick those out. So, and then that's our conversion function. So now it overrode it, but the default is still the same, right? If I don't pass that type equals, it defaults to a data frame, so these are back to being a nice data frame. But now if I come in here and say type equals array, which was one of the strings I allowed, now this becomes an ND array. And I feel like this is pretty elegant. Let's try one more. Let's get a dictionary out. So equals py, and again, I could just drag here for XL, but now I want to say type is a dictionary. And now I've got a dictionary where it has all these values listed out that, again, I can then, just like anything, I can grab that dot alice, it shows, I don't know if you saw that, like tab complete is there. So I can grab people's score and other things. So I feel like getting a NumPy array is pretty easy from pandas. It's just dot value, but getting a dictionary out once it's already like tried to convert the columns, you can do it, but why would you want to if you can just sort of like build this in and then just say, yeah, give me it as a dictionary, or one more we can do, I just want a list of these. So come and do, type equals list. And now I've got a nice list here pulled out. So anyways, that's essentially what I've got. Is that if you want to get fancy with being able to pull in, ranges, and you don't want to have to like tunnel through pandas to get back to what you actually wanted, this is a nice, easy way that you can sort of augment the Excel function. I will give you some words of warning here. Excel is a macro, not a function. In macros of like a C macro, not VBA. So as weird as this may seem, you can't do this. Let's do, I'm tiny again, aren't I? All right. If I say I want an address to be, G7, and then I want XL of address, this looks like it should work, right? No, you'll get a lovely key error that says, nope, I can't. Like key error G7, it refuses to deal with that. The reason being is that Python is not tunneling back into your spreadsheet and getting the value of G7. What happens is when this block of text is going to be sent off to the Python kernel, Excel actually like parses it and looks for these XL strings. It's looking for XL with the parentheses, with a double quote, and something that looks like a range and a double quote. Like it's looking for that. It then gets the value from G7, pushes it up to Python, gives it a temporary variable name, replaces it in your code, and that's what gets executed. So when you try to get fancy with this Excel function, it breaks. You're probably not going to run into this often, but just so you know. Other things, F strings don't work, like if you wanted to say, this is a string talking, come on thing. This is a string talking about, and then put XLB6 there, you're going to get a key error. If you try to curry it with the functools.partial, you'll get an error. So the answer is Excel's powerful, but just realize it's doing a little bit of, it's a little magic. In fact, strangely enough, if you come in and put like triple quotes of G7, this will work. But as soon as I execute it, it gets replaced with just double quotes. Like, they really, really, really want it to look like this very nice regex searchable string. Okay, that's all I've got for very advanced tools in your toolbox, but data going in and out. I think it's actually really helpful. If ever you're going to do something advanced and want to show this off and have it look good and have your code sort of very maintainable, Python's fantastic because you can comment your code. You can use white space, like all the things that you can't do in Excel formulas. And this just adds more tools in your tool belt of being able to have some pretty cool like return objects and enhancing the Excel just so that now your code is very clean and very nice. All right, we're going to take a break now. So go and stretch your legs. What? 3:10? Okay.
I just want to make I want to see if I can get the image preview on the cards, because one of the data sets that I have is.
You probably can't. I know I've if you generate the Python image yourself, like I've made a dictionary that has a nested like thing where you can actually, where is it?
But say for example, I have a data set that's and I have it in the repo that's board game reviews. And
Okay.
one of the columns is a URL to the image of the game, and it would be super cool to have it where I hover over and I can see the
Yeah, let me see. Where's the link to the documentation?
Control F for documentation.
There it is. I mean, they've got this nice big hero image and,
Right, but I was just worried that it was JavaScript that had to go get it.
oh. Are they going to give me an example with a URL? Yeah, see, they're not showing it to me.
Main image, property image.
But it just says,
It's I could also see oh, if you have a bunch of flight tracking data, I think that would be another
yeah.
interesting, you have all the stats about the flight, and then you have maybe a picture of there it's a picture of the airline
Yeah.
logo or something, that's closer to the icon thing.
Yeah, they show you it's possible, but I haven't ever played with it to see, but.
I'll see if I'm bored tonight. I do really like the being able to overload the Excel so you can actually say which version, stop turning it into a data frame,
I know why they made that choice.
Yes.
But I kind of wish, that function I wrote right there, I wish they would have done that from the beginning and had a type equals, and just, again, something the dictionary and the list, you kind of opinionated, it only works a certain, but, and maybe they were NumPy, you could just get dot values, but, yeah. I remember spending a long time for wanting just a simple, again, key, value, and trying to remember how to turn those into series, and then I was like,
We have till, again, I want to say.
5:30, or 4:30, yeah.
Is it 5:30?
It's 4 hours, right?
So 1:32, 33, 34, 35.
It is 5:30, okay.
Can do math. I love it.
Oh, we've only been an hour and a half, okay, so.
Yeah,
we're
I
on
think
track.
we're, I think we're doing good. My next part is
Copilot.
pretty short, yeah. what I want to do is, and the whole reason the button disappeared was just because it was the bug I mentioned. You have to close all of the Excel spreadsheets and open a new one.
Okay.
But you already had a bunch of stuff written in it, so I was
Yeah,
like,
yeah,
you know
yeah.
what,
That's fine.
whatever. We're gonna do
What's
this.
funny is, like, the editor wasn't there for so long that, like, my default reaction is just always reach up to the formula bar. Now it's
Yeah,
not
yeah, yeah.
easier.
Well, I guess that makes sense. I can't open two Excel notebooks with the same name at the same time.
All right, I'm gonna go.
Sounds good. Yeah.
I did see that you're able to generate plots with like C1. How do you get it to show?
So we don't get like the odd.
It's, this was- and then dot image, and it does work.
So yeah, there's another way, but that's a great example of some of the stuff Tim was talking about. Like that's an attribute of that cell. So if you change the right click on this cell that's the image, and then use somebody basically can pop out and float the image.
That's fine, if that's the answer. I saw that.
No, there's totally a way to do it though. Yeah, that's That's what the option normally there is, display plot over cells.
Okay, so that is just a
Yeah, I'm not,
web issue versus,
because it changes pretty much weekly, I don't have a good tracking. They are really, really close now. The main thing I knew that didn't work was the Power Query features in Excel. I did not think that popping the image out was not a thing, but that will hopefully be fixed shortly. I know they're getting they did the Windows version first because that was, in some sense, the easiest because they had most of the Windows dev team. Then they did Mac, and the web is kind of the last to, at least in the preview cycle here.
and one other question.
Oh, yeah.
Is there a way to like import code from another file? So, for example, with the class objects that you made, you know, there was a not insignificant amount of code involved in like rendering and displaying things. Maybe that would be handy to have, you know, that sits in the .py file, and then I just tell Excel, look at this py file, run this code, or, you know, import this code.
I think my take is in the future when that initialization section can be edited, like that's where you dump.
Oh,
Yeah, like,
Because otherwise it's like pointing to a PY file. That is basically a PY file that's like, put all your imports, your definition, just like slap it there, and then your logic lives in itself.
got it, okay.
yeah, like, you can see, like, here, these were the scalar and array conversions Jim was talking about,
All the
but
things
like,
I was putting in like cell A1, you would want to put in here.
Okay.
It still doesn't solve the problem. You still have to like paste that into every new workbook.
but,
But at least there's
At least there's like sort of a place for it, yeah. Not
Yeah.
just some random cell and some random sheet.
okay.
and
And you mentioned that's not editable yet. but
Not yet.
I've,
at some point, yeah.
I would hope pretty soon, like, I was testing some of the final flights 2 weeks ago, so. Mostly how the features, they roll out usually to the Windows one first, and then it's just kind of a gradual rollout to everything, so. Cool. I think we have most everybody back. Missing two people? When did I say? I think I said 3:15, right?
Yeah.
Okay. We'll keep it going. Awesome. So now that you've seen both some simple and some pretty dope advanced Python and Excel stuff, I really like the reppers because, like, especially from the collaboration standpoint that Jim was talking about. Like, if I'm working with someone in sales who does not want to look at my Python code, doesn't want to have to figure it out, I can set the reppers, or I can make those preview cards, and that they go crazy. So it's if you want a promotion, a good easy win. Make people see shiny things. All right, so I'm gonna talk about some other kind of features here that are part of what's nice about having it running the Python in an Excel-like ecosystem, which is working with copilots. Out of curiosity, how many folks use some form of AI-assisted code writing? Yep, me too. It basically is everywhere now, and mostly means I don't have to remember the Pandas API. So honestly, I think that's my most frequently used, that and remembering the format for a conda env file. I just say, please make me the conda env file. So as you might expect, there's obviously access to Copilot for the Python and Excel stuff. But specifically here, there's a feature called advanced analysis. The general vanilla Copilot might know a little bit about Python, but it's not like trained, like it is a very broad LLM for that. So what I'll be showing you here is a way to access the one that's specifically for writing Python code, and is in fact, if I recall correctly, basically the same underlying model as the GitHub Copilot. So like it's actually meant for code. So what can you do with that? I've tried things like if you need to start a project, like I had some folks from finance team want to know about Monte Carlo simulations. And I could have gone and looked at all the docs, and honestly, it pulled most of this from stats models docs, but it made it quicker for me to just kind of get some sample code up and going. Another example, mainly because I've been working with finance people a lot on this, but basically they had some data, they had some plots, and their task was that they were being asked to do was forecast stuff. Well, Python has a lot of really great stats models and forecasting tools and things like that that are in this image. And so you could ask, hey, help me do the forecast with certain confidence intervals and add that to my plot. So it modified the plot here and added that to what they were working with. You can also just ask for help creating kind of more general visualizations. Like here they had nothing, they just had the data, and ask for some violin plots. It will definitely, I will say it's usually pretty eager about making plots for you. So sometimes its first stab at what you're asking might be a little eccentric. And you can even ask it pretty vague questions about, like, without a lot of direction, like, can you just make a graph, a network graph of my data and not really even tell it anything else? Like, all you've given it is graph there. You could even just ask, make a visualization of my data. And another scenario I ran into was we had a bunch of like reviews from different like events and stuff like that. You can, without having to like go through and read, you can do sentiment analysis with Python and Excel, because it does have the NLTK, the Natural Language Toolbox. But even for just like a quick temperature check, you can just ask Copilot to kind of go through and summarize, like, what were the things that, top 3 opportunities for improvement was what we asked. But, so how do you actually use this? You can go from the home bar, there's a Copilot button. It pops up a panel on the side, which the visual design does change a little bit. So if there isn't a button there that says advanced analysis, you can always prompt or ask, can I have deeper analysis with Python, or do advanced analysis? Something including the words advanced analysis in Python, your choice. Then it'll say, yep, I can help you with that, and there'll be a little button in the chat to hit start. And then one of the things I really like about how this works is it makes a new sheet. So it doesn't like touch or mess with anything that you already have in your worksheet. It makes a new one, and it will go through and document all its steps as it's going through. So you can see here, like, it's made this new analysis sheet called this, or called analysis sheet. It says, oh, I'm gonna load the data. Here's a preview of it. I'm gonna visualize some categories. Here's the code. Here's the preview of it. So it does actually kind of lay out what it's doing in kind of a nice way that you can go back and edit and reuse. So let me just show you a quick example of this. Mainly because I don't want to spend too much time on it, but one of the things that has been pretty useful with this is if I'm working with folks who are maybe Excel pros, or like the sales team, the marketing team, who are not Pythonistas, they can still ask Copilot, the advanced analysis, to make them some plots without having to bug me. And usually, for the most part, it gets them what they need. So I have a worksheet here that actually I've been playing around with for playing tabletop. It has, I've used one of the ways built into Excel to get data into your worksheet called Power Query. So this is one of the things that only works in desktop versions so far. But basically, if you go to the Data tab here, there is, I don't know what I did to get that. You can add data lots of different ways. Like, and actually how I did it here is there's a URL on GitHub somewhere that has just a direct link to this CSV. I pasted that in, and with like from other sources from the web, and then basically it automatically downloads, pulls it in, sets it all up nice for me, such that when I want to use this data, I can, where is a good place? I'll just make a new one. If I want to refer to data in that table, like, yes, I could go select the cells, but what's nice, I can actually view all of the, they call that a query, because it's kind of like a database query. You can also obviously hook it up to real databases, but this is called bestiary. So if I did that, if I wanted to make this a Python cell, and then I went XL, and then I think it's the name, oops, I get it right. You can see even, mostly you can't because I can't zoom in. When I start typing here, it gives me suggestions for tables and queries that it knows about already in my sheet. So one of them here is the bestiary, so I can just select that. Let me try that again. This is, as a Pythonista, I struggle with sometimes where I click and what happens. So I want XL, and I think I hit tab. There we go, tab to complete it, not enter. But yeah, so now if I, it's not a security concern, I promise. Now we can see I've referred to that and I can just use that by name. I don't have to, and it's easier to kind of remember then as I'm working with the data. So the main thing I wanted to do here though was ask Copilot some questions because I'm trying to design a new campaign. Let's leave it here. When you start Copilot or start like the advanced analysis, yes, autosave, fine. It will start by assuming the data you want to work with is what's open or selected currently. You can definitely ask it to use any other data, but just as like it's easier for me to remember, I usually just have the sheet open that I'm interested in. So I can say, get deeper analysis results with Python. Before it makes the new sheet, it asks me if I want it to. Let's make this bigger. So you can see it's like, all right, I'm loading data from A6. It says kind of what else do you want to know and make some suggestions. So one of the suggestions is summarize the average range of, like the range of HP for each creature type. Like do dragons have more HP or do kobolds just, they're tiny. So we can see that it entered that. I could say, oh, show me a bar chart, or I could ask it for any other visualization. It does a pretty good job of looking at the data and trying to guess at things you might want to know about it. So as we kind of, this kind of makes sense here, monstrosities generally have, it looks like 3 times as much HP as any other creature here. So yeah, like I could go through and like if I was trying to, we also in the bestiary have the, I think it's called the complexity rating or the difficulty rating for each of these. I could work with Copilot to try and help me figure out what sort of party comp or what I want the enemies to be to kind of keep that challenge level or difficulty rank the same. So yeah, and I also had done, this was, I wanted to show an example of kind of using some more of the machine learning sorts of packages in the container, because that really is something that is very hard to do in just vanilla Excel. Like you can probably implement some machine learning algorithms, but it's going to be real painful. But basically here is an example of using scikit-learn to basically do feature detection on things in the bestiary. So like, and then using Seaborn to make this like ginormous and hard to zoom in on. Quad plot, like I wouldn't know how to make a plot like this in Excel. I think I would just give up. But here it's, really pretty easy. I think it's like a few lines here. And you can have a really nice plot to review your data with. So I think in the interest of time, I might continue, but I strongly encourage you with any of the notebooks that you've worked with today, you can, if you don't have data in them and just want to play around with stuff, if you go to the, if you say insert Python somewhere, these things on the side will insert samples. So there's some data to play around with, and you could ask Copilot questions about that to just kind of see how it might work for you. So I think you're next.
Okay.
Yep. Is there any questions about that or comments, concerns?
I have a comment.
Oh, yeah, okay.
Yeah,
Comment
so
me.
I'll just say, one thing I like about the advanced analysis with Copilot is it's not the LLM that's like looking at all your data and writing the result. You're instead using the LLM to write Python code that will analyze the thing. So it might not always like do the right analysis if it writes the wrong Python code, but what the Python code it writes will actually be using actual pandas methods, stats, like you'll get real results that are repeatable over time. So I like that better than just, I think there's people who assume that I give a big CSV to an LLM and say, hey, tell me what I should do next. And it's like, it gives you some answer and there's no metrics, whereas here you can look at the code that it wrote, agree with it or not, but like at least you have it and you can inspect it, so.
Yeah, no, that makes a lot of sense. I think I was just gonna see what comments it wrote when it, just real quick, where is there? Yeah, so like here, it's the start of some of the cells that Copilot was writing. Oh, yep, sorry. And you can see like it actually has documented what it's doing. So when I found, it is still an LLM, it does make mistakes, but honestly, they're usually pretty easy to find because it'll be like, this is the description of what should happen. This is not what's happening. And so you can be like, oh, well, these are in the wrong spot or you're missing a column value or something like that. So, dope. I will close that and open you a new sheet just to make sure the buttons show up. But yes, cool.
Okay. Let's make sure we've got it here. Yay, we've got Python. Okay. All right, we're going to try to sandwich these over here and zoom in. All right, I'm going to talk about Anaconda Toolbox and Anaconda Code. As I do this, I want to explain what this is and what it isn't. So we've been talking a lot about Python and Excel, which is built into Excel. Microsoft developed that. You type equals py and you write your formulas. And it runs in a container on Azure using the Anaconda distribution. But as far as Python and Excel is concerned, that's the only piece that Anaconda has. Microsoft and Anaconda had a partnership, but mostly it was Microsoft, integrating this into Excel. The Anaconda Toolbox and Anaconda Code are add-ins that Anaconda developed that you have to install as a side panel add-in in Excel. The Anaconda Toolbox is meant to help you get started with Python and Excel and add some enhancements, but it's not required to run Python and Excel. Like Python and Excel is its own, it's built in, you don't need the add-in to run it. And then Anaconda Code actually replicates some of the functionality of Python and Excel, and I'll get to that. But let's start with Anaconda Toolbox. So If you guys haven't already installed this, you go to the home, hit the add-ins, search for Anaconda, and install the Anaconda Toolbox. And once you install it, it's going to show up on the formulas bar over here in the Anaconda group, and now we've got Toolbox and code. So I'm going to open the Toolbox. I'm already signed in. If you're not, you need to sign in. It's a free account. You can sign up at anaconda.com. Okay, but so hopefully, I guess if you have trouble with that, then raise your hand, we can work on there. So the Anaconda Toolbox really is designed to just sort of jumpstart people using Python and Excel. It's got 4 different pieces. So we've got this Visualize with Python, an AI chat, which is a worse form of Copilot, if you will. And then 2 different ways of connecting, sharing data sets and code snippets with other Anaconda account users. So this is sort of like collaboration within Excel. And then there's Chat Assistant. The one I want to show is Visualize with Python. So we already saw how Copilot is very eager to make charts. This Visualize with Python lets you sort of point and click, like, have a UI for making charts. So first of all, we're going to need a data set. So let's go ahead and grab the same one that Sarah was talking about. We're going to come grab this. Yeah. Insert the scatterplot example. So it's not exciting like the bestiary. This is just the iris data set. It works. Okay, so then we can close that out. We've got a nice table that they've named iris dataset 2 for us. That's very nice. And they've gone ahead and made a Python image for us like that. So let's try to recreate that using the Anaconda Toolbox. Let me zoom in a bit. Okay, so again, coming back here, you're going to click on Visualize with Python, and then we need to make a new chart. And we've got different styles, so we're going to just use a scatter chart, which is what the example is. Okay, once we've got this, you're going to choose the data set. You got a couple different options. You can choose entire sheets if, just sort of like your data is just on one sheet. Any tables that are defined will be listed here, or you could manually choose and then like drag a range. In our case, we've already got a predefined table. You pick that, and now the X and Y axis you need to define, and because you pick the data set, it knows what's here. So let's see, this is sepal length against sepal width, so we'll pick sepal length, sepal width, and then we can go and do a preview here. And that looks almost the same. I guess we're missing a title. So let's go back and add the title, which was sepal length and width analysis. Okay, and then so we've got the preview you can look at. There's also code that shows you the code it will write. So at this point, it hasn't written anything to Excel yet. But when it does, it's not actually gonna create the chart for you. It just writes the code in an equals PY cell and then lets Python and Excel generate the chart. So this is the code that it will write, verbose a bit, but it's got options for all the different tick angles and things that if you aren't a Seaborn expert or a Matplotlib expert, like we sort of boiled all these things that you might want and put them in there. So once you're ready, you click create, and then it says, where do you want to drop the chart? So we'll just put it there. And then you'll notice, here's our chart, which, all right, we'll make a bigger reference for it. Looks nearly identical to that one. But importantly, if we click here, we can look, this is, again, it's just a regular equals PY cell. So if you want to use, Copilot or some other LLM to make plots, great. If you're very much a point and click, want to see everything, then the Anaconda Toolbox might be for you. The nice thing is you can go and do other work and then come back and click on this, and it brings you right back into the menu, like you can re-edit your charts and other things. So let's see, right here, this is kind of a boring chart. So we see that there is a color by, size by, and style by. So let's color by the species. We'll hit apply. And now this is the magic of Seaborn. We now have nice colors, and it gave us a legend. If we were worried how this is going to print out in black and white, we could, change the style to also be by species, so that now we actually get, different colored, markers or whatever. So that is. Yeah, I think we've got all that covered. Okay, so who here has Anaconda Toolbox working? I know a couple people were struggling with it. Either their admin policies didn't let them install add-ins. Do people have the toolbox running? Okay, then we're gonna do an exercise. If you haven't already grabbed the iris data set, and come into the toolbox and make a pairwise plot. So we're gonna make a pairwise chart. We'll grab the same data, the iris data set. And then you can either pick the row and column variables, or you can just pick which variables you want, and it'll do like an all pairs collection of them. So I'm gonna do that, and we're gonna do all pairs for, basically the 4 numeric types, which of course grays out the rows and columns if you're already doing it that way. We're gonna color by the species, and then let's go ahead and see what this thing looks like. It's gonna be enormous, because again, it's a giant quad plot. And this one actually takes Seaborn a bit longer to make. But there we've got what I think is a pretty cool looking plot. So the default is, where they are different, like sepal width versus sepal length, you get a nice scatter plot where it's the same sepal length against sepal length. It would just be a straight line, so instead they give you a histogram. And yeah, it actually has other interesting kernel density estimations and other fun things that I didn't know existed until suddenly you're like, okay, I guess I would call those contours, but again, like Sarah was saying, if you want a promotion, including these graphs will get people talking about your spreadsheet, so just saying. All right, any questions about Anaconda Toolbox?
How'd you get the iris data set again?
Oh.
I'm trying to follow the directions here of
Sorry, yeah.
the formula, insert Python, and then tour.
Yeah, so if you click insert Python, it will insert a Python cell, but also pop over here. Are you seeing this where it says like tour samples?
Yeah, I'm in the online version.
Oh, and it doesn't have it? Okay. Sorry, my bad. Yes, I know.
The iris data sheet is in the repo. If you want to throw out data.
Okay. Sorry, yes, this is the challenge where you assume Excel is Excel, and then you realize that it's 3 different entire code bases that roll out slowly. So, okay, so we covered, again, the toolbox is really about enhancing Python in Excel. So that's what it's for. Anaconda code we're going to jump into now. And it's bundled with the toolbox, but really it serves a separate purpose. So Anaconda code, let's jump over here. All right. Who here is familiar with Pyodide? Anyone? Some people know Pyodide? All right. Pyodide is basically CPython compiled to run in your browser using WebAssembly. So it runs almost as fast as it would, when you've installed Python locally, but it runs in your browser. And it's a pretty cool technology. It's actually quite mature. It's several years old. So these Excel add-ins, this actually is just a web page. So the way that you develop these JavaScript add-ins, you make a web page, and then inside here, this is just a web view that Excel injects this office.js file so that you can then talk to, read and write values from the grid. So simple in concept, but powerful because this is a web browser. So there's now a version of Python that runs inside a web browser, and an add-in is a web browser. And so Anaconda Code basically takes Python, and instead of running it on the cloud, it runs it right here, right inside of Excel, essentially. There's some advantages. So you're not sending data, so it can be faster. WebAssembly, however, is single-threaded, single-core. So, in theory, your Azure container could have like GPUs and 8-core, could run your code significantly faster if you're doing a big simulation. Really, it's more like a latency versus computation power question. And then there's also not the same limitations. So because you are in a web browser, we do have web access, or network access. So Anaconda Code lets you customize the environment. You can install new packages in here. It has a new run mode that I'll demonstrate, and then also some user-defined functions. So I'll walk through these, but realize that this is like almost reimagining what Python in Excel is. So this is no longer writing equals py cells. It's doing its own computation, and really was an idea of what could we explore and reimagine that we could feed back to Microsoft to say these would be some cool features to eventually roll into Python and Excel. So it's definitely never going to be as robust as Python and Excel, but I think it's pretty cool. I'm the developer on it, so if you want to come talk to me afterwards, yes. Yeah, very biased. Okay. All right, so let's jump in. All right, so we're going to come in. Let's just come back to the home menu. We're just going to create a Python cell here. All the editing is done over on the side. So, 1 + 1, we can run it. It uses the same control enter execution. We got 2. But if you look at the formula bar, it's ugly. And I put this comment in of like, don't ever edit this directly. I'm getting fancy here. So you really want to edit it just in the side panel. All right, so if you ever create this and get like a name error, then it means that the add-in didn't register because it has to register a custom function to work. So usually the solution is just you uninstall the add-in and then reinstall it and things should work. All right, let's go ahead and add a package. So we're going to go to the third icon over here, our environment. We can edit it. We've got actually different versions of Pyodide that they keep coming out with new versions, and these are all tied to, Python versions. So this one I think is 3.13 maybe, or 3.12. All right, but we can add. We're going to come in here, and it's not all of the Python packages, unfortunately. It's basically those that have been compiled to WebAssembly and pure Python packages. Those two will work. But some of your other ones, like TensorFlow and things, they're just not available. So another limitation of running it in the browser. But let's get Network X. All right, we'll add that. Polars is here. So I know that's one that people want. So add those, add packages. This is showing us what's going to go. We'll save changes. And it will now initialize with those new packages. It is downloading them. If you guys are following along, this might take some time the first time because it essentially is downloading Python and SciPy, like all the same thing as if you were installing it. In subsequent versions, these packages will be cached. So they'll be loading faster, but just first time it's a little bit painful. Okay, once we've got that, then we've got the second icon. This is what I call imports and definitions. This is equivalent of like the initialization section in Python and Excel. This one is editable right now. And so once you've brought in a new package, this is where you can, import Network X as NX. We can import polars as PL. Run these, and now these, will be available to all the cells that use them, along with some other helper functions that are already in here, and you can define other classes. All right, we're going to go back here, and all right. So when I want to make a new cell, like click back, and then we see a list of all the cells. This is kind of like the editor. So we'll make a new cell, and we'll drop it into B2. All right, let's start writing some code. First of all, I will say data equals, here instead of the Excel word, I have capital ref, because as I mentioned before, Excel is a macro, so I wanted to make this as macro-like as possible. So it's capital ref, but it's serving the same function of getting data from elsewhere. So this has tab complete on the iris, tables. If you wanted to, you can click this ref button and actually go like select your cells, but here we'll take this, and I'm just going to copy this so that I get it right. All right, so we now have a polars data frame that's using this. We'll run that. All right, so we've got a couple things. One is it's built out to the grid. We can actually change that. It's got the similar Excel values and code objects. The default right now is to spill to the grid. We also have a little printout here under this, just sort of like what you'd get in a notebook. So sort of the text representation, and then also the data gets sent back out to the grid. So if we change this to the code object and rerun it, then you get this same card view style that we saw with Python and Excel. Notice the icon here is different. It's like the angle with a slash, I didn't want any confusion that, it's like, oh, I've got a Python cell, and then I've got another Python cell, like the square bracket PY means Python and Excel. The angle bracket with the slash, that's Anaconda code. But essentially serving very similar purposes. Although two very different kernels, you can't just like refer one to the other. One's running in the cloud, one's running in your add-in, so the two kernels don't talk. So that's that note. All right, let's do some other fancy polar stuff. So we're going to go to B4 and make a new cell. I was going to copy this in. All right, I'm getting a reference back to B2, and then I'll do a group by species, and then do some aggregations. We'll get the count, the sepal length, and everything else. So anyone who's done polars, I don't know if this excites you, but polar seems to be the new hotness. I don't know, people are down on pandas and positive on polars, but all right, okay, so we can, do some polars things. All right, one question you might be asking is why I had to redefine DF. So Anaconda code has two different run modes. So in the cell, there's isolated and linked mode. Linked mode is what Python and Excel does. It runs row major order, and every cell can refer to previous cells like their local variables, just like a Jupyter notebook. Isolated mode, which is the default for Anaconda code, each cell is fully isolated. So just because I defined, DF up here does not mean I can use it down here. I have to actually explicitly grab a new reference to it. And you might be asking what the benefit of that is. It's that now you don't have to go in row major order, and with Python and Excel, whenever you edit one cell, like they all rerun to make sure that like there's never any stale data. With this, it's more Excel-like with the dependency. Like each cell will only recompute when its dependencies change. And so you could put the cells wherever you want, and you think the only downside is you have to explicitly refer to things, that like DF from 3 cells ago doesn't exist unless you redefine it here. All right, so I want to demonstrate that with a fun example because I like Mandelbrot sets. So, all right, we're going to go to cell A10 and put 128, just a regular standard thing. All right, and then in B10, we're going to make an Anaconda code cell and paste in this big chunk and run it. And we get a nice image out. And we'll make a bigger version of it, not that big. Okay, so it's a Mandelbrot set, but in here, I've got a reference. So the pixel density is referring to cell A10. And I think this is a fun demonstration for anyone who's wondering like why you'd ever want Python in Excel. This is a good demo because as you change this, like your image updates and you can, get different densities. I know you can do this with a Jupyter Notebook, but usually you have to like decide on IPy widgets or some other like thing that you can mess with. People really don't want to have to like go up and like manually type it in. But in Excel, if you've got a reference and you change it, people are very used to using Excel as sort of a very quick and easy dashboard. You color this, you put a text above it, it's like change this to update whatever, and it's intuitive for, the pointy hair bosses and other people, like it works for them. So, but as I'm doing this, you notice that, or maybe you didn't notice, none of these polar cells recomputed. That's because this Mandelbrot only refers to this cell. So as I change it, it will change and recompute that, but these other cells don't rerun. So that's the benefit of like isolated mode, is that you can have lots of different isolated Python computations, and unless they're all tied together and need to run together, they won't. All right. All right, user-defined functions. So we can come back in here. This is a really cool thing. I'm going to just do a simple @UDF. This is a built-in thing. I can now define my func, take x, and I'll just return x plus 1, and I'm going to run that. Because I decorate it with UDF, this now is available here as anaconda.myfunc. So we just registered a new user-defined function in the grid. And I can call it without actually having to type equals py. I don't have to know that like this was defined in Python land, and now in Excel land, I can just call it. And it operates just like anything else would. This can, right, equals that of B1. And change that, that's going to change. So all the standard things, but we've now registered something from Python and exposed it as the new Excel function. So let's get fancy with this. We're going to do some network X magic here. All right, so this one I'm going to register a new user-defined function. I'm going to call it org.structure and put nested as false so it doesn't always nest under anaconda dot. That just sort of was a way to keep your functions tidy. All right, I'm going to take in edge list and do some shortest path computations on it. All right, so I'll register that, and then let me grab some data here. Okay, so we've got a simple edge list. This is, manager, employee here. People might be familiar with this. You just have, Alice manages Bob and Caitlin and Doreen, and Bob manages Ellis and other, like, you could imagine just dumping, this is a standard edge list, and anyone knows this is going to make a graph. But from within Excel, trying to use some kind of a graph thing is going to be really complicated. If you want to know, who's in Alice's org within 3 levels, you could do that. But within Alice's org, is that 3 levels? Is it 5 levels? Like trying to write a formula that has an unknown level of like expansion, really hard. But Python is very easy. Network X, you turn it into a graph, call a function, you can do fun things with it. So, all right, so we registered this org structure, and it lets us take an edgewise list, a start and an end, and it'll just find the path for us. So now that we've registered that, I can say equals org dot, and tab completes. I put in that, and then I say I want to map between Alice and Zoe, all the way to the end. And there's my list. All right, Alice manages Doreen, who manages Joaquin, who manages Quinn, who manages Vanessa, and Vanessa manages Zoe. So there's our list of how Alice and Zoe are connected. That would be really hard to get that in Excel, but using Python and just sort of exposing it, now someone's like, oh yeah, I want an org structure. I mean, you could even get fancier and say, how are Xavier and Zoe related? And because it's the shortest path calculation, it'll actually tunnel from Xavier back up to Walter and Bob and, like trace through the org. How are the two of you, like, who would you need to talk to if you needed to like get permission for them to do some work for you? Like, useful. So again, not that like the finance team needs to understand Python, but if you could start exposing functions to them and say, hey, this is just how it works, then it makes sense to them. You can actually add some, docstring stuff. And then when they go and actually look at the function, they'll see the docstring stuff here. So like you can make it as Excel-like and Excel-friendly as you want. So that is, oh, and yes, also because this is just regular Python like I was showing before, you can use it with other functions that are native to Excel. So we can transpose it if we wanted to split that out wide or get the length of it or whatever else we want to do. Okay, so questions on that? Okay, so, question over here.
Like, so you define those user-defined functions. If I wanted somebody else to use them, but they also have to have the toolbox installed, presumably?
Yes, yeah, they'd have to have the, well, I mean, what you would do is you would send them this file, and what would happen is when they open it up, it would pop up and say, this spreadsheet basically needs to install this add-in, and they would have to allow to install it, but it should prompt them. Like add-ins are pretty good, where they can basically like put a tag on the file that says, I need to exist for this file to work. And so then when the file opens, Excel's like, this add-in's claiming that it's absolutely necessary that you install it. And in this case, it is. But okay, so all right, Anaconda Toolbox is to help Python in Excel. It is not required to run Python in Excel, but it has the visualization, it has an alternate LLM and some other code sharing things. Anaconda Code reimagines Python in Excel. The two are bundled inside the Anaconda Toolbox add-in. For those who have wanted to, install things or, have issues where Python in Excel right now has limitations, Anaconda Code might suffice for you. Realize it has its own limitations too. Not the least of which that a lot of organizations block add-ins because they don't want people just installing random things from the web. In one sense, it's significantly safer than VBA because it's running in a browser, so it has the same browser sandbox. It can't access local files, it can't read your hard drive, it can't do anything. However, it is running JavaScript, so it can just make a JSON call. So if you were somehow worried about like data exfiltration or something, like, yeah, it has access to the one workbook that you're using, and it can make network calls. So if that worries you, okay, then that's usually why admins like tend to be more careful, but that's like the only security concern. Otherwise, it can't fry your computer or do anything. And has some fun things. So that's what we got. Oh, one last thing, just because we can. There's also a WebAssembly version of R that runs. So we went ahead and popped in R here. So if you guys have colleagues who use R and want to use R in Excel, it works. So I won't show that, but because this is Python in Spreadsheets, but it's there if you want that. All right. Should we take another break? And then, okay, another break, and then Sarah will wrap us up with lots of cool stuff.
Let's come back at 4:10 then.
4:10? Okay. We're talking about R, because there's interest there. So, okay, so yeah, on the environment page, you can toggle and look at R, and we've got an R environment as well. So there's a project that I think some developers at Posit have created WebR, they've compiled it. So same idea with CPython compiling, it's like that. So there's only like a couple versions, but then there's most of the CRAN packages. There's like a ton that they've done, yeah, literally 21,000 of them. Some of them will like pop up warnings because they depend on like curl or some other like low-level operating system package that hasn't been compiled for WebAssembly. But like most of the ones I've tried work. I mean, so you can get like Palmer Penguins is in here, and you can add that. Run it, and then I'll keep that running. We also then have the same like imports and definitions, so you can, by default, we import the whole tidyverse, since that seems to be like the right way to do things now. The cool thing to do, yep. Yeah, and then when you want to make so equals, well, you come back and just you make a new cell, and if it happens to default to Python, then you just change it to an R cell. And then, let's see, the tidyverse has the MPG data set. So there's the MPG data set. I don't know, I'm not a strong R user. I did just enough to like pull this in, but.
Yeah, but so this is using the Anaconda plugin. This is not a native Excel.
Correct, yeah, you got it, yeah, I know, now it's weird. You got to install the Anaconda Toolbox and then use Anaconda code to get R. But it's there, so. And then, what is it, Penguins, I think? Oh, wait, do I have to? Oh, yeah, I guess I got to do Palmer Penguins. Yeah, there's our penguins. Okay, so yeah, it's a similar. So you install the package, and then you still have to do like library thing to like actually import it. Yeah, and then ggplot works. So yeah, where's some? Anyways.
Thank you, I appreciate it.
Absolutely, yeah. Spread the word, because.
That is so dope. I didn't know you could do R.
Well, and there's some art conferences that I was wanting to go to, and like,
Why are you not?
well, we literally released this in like April, and like all of their cutoffs were in like February and March, and so I was like, it's gonna be weird if I like submit this proposal, and I'm like, no, I promise it's coming. Like most conferences are like, if it's not, I know, no, they must have had been burned by too much vaporware, so. Anyways, yeah, I would like to go and spread the word, because this is, I have a feeling there's a lot of R and Excel users who like overlap a lot.
Is there a Julia WebAssembly?
There is. I haven't poked at that.
You're just like,
Well,
don't ask.
There is. So in theory, you could pull all the WebAssembly thing. The thing is, though, like Julia and Excel, how much overlap is there in that Venn diagram? I feel like Julia tends to be, they're opinionated for reasons, so they might eschew Excel. I don't know. But,
Thank you.
yeah. What was your name? B. Okay. We'll talk more later, because.
I can't remember if it was like astrophysicist or something. I was, back when I was a postdoc, like doing a tutorial on like what is Jupyter notebooks and stuff.
Mhm.
Just like basic Python things, and a lot of them use Jupyter. And I was just like quite surprised, because normally I think it's like a stats or pure math people. I don't even know
Okay.
who really uses it.
Let's see what it does. I don't know.
data set, like just defined in the R kernel?
Well, I had to install it.
Oh, I see.
So over here,
Got
yeah,
it.
you install Palmer Penguins, and then it's,
Shit.
hey, look at that, some nice ggplot.
Hey, nice.
All right, B, there's your ggplot in R that an LLM wrote for me, so.
Nice.
Same restrictions, it's got to be static charts, no dynamic, you're not going to get a shiny app in Excel, it's not going to happen. Yeah, but that's just shiny, it's not shiny in Excel. That would be, I would go see that.
I'm hoping with the
No, I know.
interactive, like.
I'm really excited.
I've tested it, like,
Okay,
but I don't know its timeline or anything really. But that would be so cool.
Yes.
'cause, like,
I know, I want dynamic charts, I want to just mouse over and see like hover tool, just that.
Yeah,
And
just see what
zoom,
hovers.
like, so cool.
Yeah.
All right,
I should probably get started. Although we're
No.
missing some people.
did we say 4:15 or 4:10?
Oh, did I say 4:15? I don't remember.
We can wait a few more minutes.
Yeah.
but-
This is so cool. Now, now my brain is entirely sidetracked. Let's write some R. No.
Oh, did you do R back in university days?
I did a little bit, but mostly when I first moved here to Seattle, I hung out with a lot of R ladies and Pi ladies meetups. So
Makes
like,
sense.
even though I wasn't doing a lot of R, I knew a lot of people who were doing R, and I heard tidyverse thing, like there was a lot. But let's see. Doop.
All right, yeah.
Huh?
You want to start?
Okay.
People wondering whether you can.
Okay. Yeah, so welcome back to our kind of final section here, bringing it home stretch. But yeah, so we've talked a lot now about running Python in spreadsheet tools with add-ins and Excel. So what if you need to do it the other way though? And I think kind of the main reason I've always had to do the other way is just my data sets were too big. Excel and most spreadsheet viewers are GUI apps at some point, and usually they have a data size limit, so I can't just go opening my like 3 gigabyte file of all of the Magic the Gathering card data set in Excel without just crashing the whole thing. So this, amongst other kind of categories, are great opportunities to use and work in Python to work with your data, manipulate, analyze, and you can even save it back to a spreadsheet form, possibly in a condensed format that won't crash it for later use. But basically, raise your hand if you've used pandas before. Okay, yeah, cool, this is great. Everybody knows pandas, we're good. I will then kind of briefly cover what your options are like for pandas features, then that will help. So this notebook is in the repo. Don't worry about necessarily having to write as I'm going. I'm just working here in VS Code, using normal VS Code things. So I'm going to import pandas, and basically there's four main kind of tabular data formats that pandas is pretty cool with. Excel, ODF, which is the open office sort of formatting. CSVs and JSONs all work super good. So I have an example in our repo here. I have, because here I can actually make things sufficiently large. I have a folder of sample data that has a bunch of random stuff in it, including the iris data if you want to play around with that later. So yeah, pandas just has a read CSV. We grab the Animal Crossing fish data, and ta-da, we have this in here. You might notice that this is a slightly nicer preview than you might normally see in a Jupyter notebook. That's provided by the Data Wrangler extension for VS Code, which if you have to look through a lot of data, I might highly recommend it. It's really nice. If only because it just gives you that preview. It does lots of other things too, but Data Wrangler, yo, shout out. But yeah, I don't have to just keep writing head or like show me I can just like look at the whole table here at once. Works just fine to load directly from an XLSX. And you do have some control. I commented this out because this gets very long. But there is lots of ways you can control different parts of that import process. Some of the main ones are if your spreadsheet has multiple tabs or sheets in it, if it's ginormous and you only need the one, you can specify just the one. And Pandas uses a number of different engines on the back end to handle these loading or importing those different data files. For the most part, it'll pick the right one. Like, it'll look at the extension, it'll figure out what the best option is. If you're having trouble or if it's not parsing it correctly, you can manually specify, especially if you're working with older file formats, like technically the XLS, which is not XLSX. It's a much older, basically, wild, wild west for security. There's no, like, this is definitely the case where you would see, like, would you like to run all the macros pop-ups all the time? And there wouldn't be a lot of stops on that. So, point being, if it's not, it should automatically pick the right one, but if not, know you have some options. So here, we're just importing a couple of the sheets from the sports data here. You can also see it has identified different types of data here too, with the icons. And I had some, just to prove to myself that it would actually, some of these other engines do require other install prerequisites. So it'll prompt, like if you try and use the engine and you don't have the package you need for it, it will tell you. But this ODF one requires ODF Pi. So that's why that's a part of the environment here. And something, when I'm working with spreadsheets of kind of unknown origin, I tend to make a README sheet. Like, I always like trying to document what I can about the data set. So I try to capture what I know about the data in that first sheet, and then, so it's been pretty nice. I can mirror that across to Python, or if I know where the data is coming from in Python and I have like a dictionary that's like all the attributes that I know about it, I can send it backwards to the spreadsheet. We have lots of options for the rows and columns stuff. You can cast the different columns to different types, because often it's pretty, it is, I find, somewhat bad, like unless it's an obvious int or float. Usually it just jumps right to object. I don't care, it's just an object, so you can be more specific there. This, kind of to get a little bit fancier on some of those conversions, we have, so this Animal Crossing fish, it's just the fishing index data. You'll see that the way it's formatted is like every month, if the fish is available, they give it like a time range or something like that. That's not super helpful, so that would probably be, if I was the data scientist in charge here, I would maybe try and figure out a better way to deal with that data, because really there's actually just a daytime slot, a nighttime slot, or all day. So like having it written out as something that's really hard to parse doesn't really help. So what if we just turn them into enums, where we just had AM, PM, or all day? So I just wrote a very simple else if sort of thing to replace that. And then we can, as a part of importing the reading the CSV, we can say provide an option called converters, where we can say, all right, for the January column, I'm just doing this for one of them, use the time of day function to kind of fix it up. So when we run that then, you can see now we actually have enum values here that are a little bit easier to work with subsequently in Python. We could, set up pandas filters and stuff on that without having to like continually do annoying string stuff. Yeah, so if you want to go the other way, you've got your data frame, you've got everything set up in pandas. Really, it's about as easy. You can there's a Excel in pandas, an Excel writer. So the easiest way is just using the method on your data frame to Excel. Like, it just takes a name and you're done. If you had, say, multiple pandas data frames that you were trying to kind of smush together into a sheet, that's where basically you would create an instance of this writer class. So that's why we have the with this as writer. Then basically you could just go through on each data frame and say the toExcel function takes the writer as an argument. So if you don't provide just a direct file path, you can say, here's the writer, and it'll add to that. With pandas, it's pretty straightforward and pretty nice. I have some suggested options for exercises here. I want to continue because I'd rather give out some cool prizes and do a fun game at the end. So the kind of other main package tool that you have available in Python to work with spreadsheets is OpenPyXL. So if I come back here, I can read. So I would say like pandas is definitely the level of your options is kind of like I'm at the bowling alley and I had them pull the gutters up, the gutter bumpers up. It's really easy and pretty straightforward. OpenPyXL is there's not even gutters. It'll just go like 6 lanes over. You have as much control here as you want to have. When I mentioned that you could like turn a spreadsheet into a zip and like unpack it all, basically this OpenPyXL will fully parse that whole structure. It does expose most of it very Pythonically, so there are easier ways to use it, but if there's something really like you can actually change like authentication requirements on the spreadsheet. So like hypothetically you could add encryption, you could take encryption, you can do the kind of like very metadata-y things that really pandas wouldn't be able to help you with in terms of manipulating the spreadsheet. So I also noted there's a few other, like I say these are the 2 primary ones. They're kind of like the 95% of cases will fall in one of these 2. There are some other options if you want like a pure Python library or ones that work with older file types. So there's that. And OpenPyXL will need Pillow, the package, to work with images because it doesn't have that built in. So if I wanted to use OpenPyXL instead to load a workbook, this is kind of what it would look like. I'll select my kernel. Good. So, yep, we've just got the iris data set here. If I were to, I just want to prove that that's something. Okay, we'll go this way. So yeah, this is what it looks like IRL. It's got this data, it's got a plot in it. And here, I can look up individual values. So here I'm printing the value in G3. So it has the concept of a workbook and worksheets and an active worksheet. So there's, that's kind of what the active part here means. By default, the active is just the first one. And then you could do, there's also properties on the workbook once you've loaded it, things like what sheet names are there. There's only one in this one. Some things, some options for the load workbook that I have found pretty useful. Sometimes if it's one that has a lot of like macros or other things, and really all I care about is the data, just doing data only, especially if it's taking a long time to load, can help a lot. So, as well as read only, if you're just looking to read data from it, because it definitely takes a lot longer to load if you're looking to edit as well. So those are some tips for that. I think that's just a duplicate. So you can also, so let's say you don't have a spreadsheet already and you're doing your analysis in Python, you're a Pythonista, you just don't really care about the spreadsheets, but when you get to the end, your boss is like, I need to share this with my super or whatever, and they want a spreadsheet. So, okay, we can actually construct them from scratch if we wanted to with OpenPyXL. So we can literally just declare a new workbook. You can set what the active worksheet is. You can assign data directly to cells. So you say worksheet and A1 equals whatever you want it to be. You can append whole rows or data frames, things like that. It does know how to properly convert dates. So when it does store it into the sheets, it does use the right ISO standards. And then just when you're done with it, you just hit save. So if I were to open, I should have a scratch. Did I ran this? I passed it. It's right there. Okay. Cool. I can see, I didn't really put much intelligent in there, but yep, I can see I made a very tiny spreadsheet with some data. Awesome. So that's kind of like the basic route. You can also, like the theme here is you can always make it fancier. So here I'm going to make another workbook from scratch. Here I've written some data of my favorite magic cards. So we've got that stored as a list of lists. So I could iterate through that list of lists and just append that data to our worksheet. Then, if I wanted to maybe make some of the headings bold or change the colors of fonts or make cells different sizes, like literally the preview size, you can do all of that with OpenPyXL. So here, I'm just going to do something relatively simple, which is change the font to bold for the header row. So I'll do that. Another interesting option you have here is OpenPyXL also allows you to use the formulas in spreadsheets. So kind of weirdly the opposite direction of user-defined functions, you can use any function that's defined in the spreadsheet in Python. So maybe like somebody's keeps telling you, no, this is what the forecasting says, here's the functions that I use, and you're like, okay, now I need to do like a comparison and show you how that doesn't match the Python and whatnot. You can literally use the same formulas that they're using from Python. So I truncated the list because it's quite long, but these were all of the functions that were known in that spreadsheet that I could load into Python. And you can just call them by doing something like this. So I have my active worksheet. I can say in C5, put this formula, and it does it. And then when somebody opens it, they will see that formula in that cell. So you can really preload everything you want in that spreadsheet for them to use. Similarly, you can also make charts. So here, I'm just declaring a new chart, setting some things like axes and titles, kind of just how I want it to appear. And then one of the things that I found somewhat confusing was OpenPyXL has this concept of a reference. It's really pretty much the same as talking about a slice, like any of the ways that we've talked about that the XL function can refer to data in Excel. Like, there is a defined standard for what a reference is, and that's basically the same thing. So a cell, a slice of cells, a name of a table, all of those things are considered a reference. So here, I just, some of the functions, especially for charting, require you to use Python to create a reference, which here mainly it's just writing out rather than writing in strings the text version of the slicing. So we'll do that. We'll add the data to the chart, add our kind of categories or the labels to the chart, save it, and then save our worksheet. So then if I go card data. Yes. Card data right here. Ta-da! Seems very simple, but the cool part was we were able to do all of that in Python. My headings here are bolded, and even it is a proper, it's not an image, because you can see as I've selected the chart, it's highlighting the X and Y axes here. So someone in Excel could continue to edit this chart here, no problem. But we were able to make that spreadsheet native sort of, and even if I click here, this was the cell with the sum. So somebody can continue to edit that exactly as it is. Yeah, so those were kind of the main things I wanted to highlight out of that. Let's come back. So, we have till 5:30, yes?
Technically, yeah.
Technically, yes. I'm gonna skip to the fun part. And by fun, I mean I have some prizes to give away. So hopefully that makes things more interesting.
Question.
Oh, question, yeah, sorry.
If I'm working with Office 365 online,
Mm-hmm.
how would I connect? Instead of having a local file on my computer, is there a way for me to connect to a particular spreadsheet that way?
So, you're inside a spreadsheet on the web version of Office 365.
Right. How do I get OpenPyXL to talk with that spreadsheet?
OneDrive and sync. I mean, yeah, I don't know of a way, unless this is speculation, but there are APIs into the Microsoft Graph, which is how you do access all of your data on Office 365, and you could probably, with anything in Python, you can probably make it work, but you could probably script something to scrape the data file down from your Office 3, from that way, work with it and push it back up, but I don't know of any obvious, or do you know of any way? Yeah, I would, if it were me, I would probably, if possible, have a OneDrive local synced file that I have that access, yeah.
Yeah, I was gonna say, one of the benefits of OpenPyXL is you don't need Excel installed.
Yes.
Literally it's just Python working with the raw XLSX format, which is nice. With Excel on the web, though, it's in Microsoft Graph, I literally think all the pieces, instead of sort of the zip file, I think they're just sort of scattered around a database, and it recompiles it on the fly. So, yeah, probably the easiest I would guess is syncing it locally so that it becomes an XLSX file, and then lots of things can talk with that. But that means that then you need to resync it up with, It's going to be more complicated.
It's not,
Certainly.
yeah, not a great option, but, yeah, what,
It is what it is.
yep. Yes. Cool. So, my last thing I've got here for you, do folks like Tetris? Yeah? Okay. Did you know that there are also Excel sports in competitions? Like, I watch a lot of speedrunning of Tetris stuff. That's really impressive. I've also watched some of the live streams of Excel esports, and I feel like it's exciting, maybe? Anyway, not the best setup but what is cool is the competition actually publishes all of their, like, the questions, because how the format for the competition is basically you have 30 minutes, they give you a problem, and you can, you use Excel, mostly it's like Excel IT pros that then have 30 minutes to try and solve it. But I would say we can do a fair bit better because we have Python, and that makes it a lot easier. So in the tutorial repo, there is a file in the, just in the base of the repo called Excel esports. Tetris, because that seemed like an actually fun data set to work with. Or we're gonna close all of them. You just take a nap. Don't worry about it. Okay, there we go. So this is the, it was from the Battle of 16, September last year. But yeah, so basically the setup here is, if you were playing a classic game of Tetris on the NES, what score you get is based on how many lines you've cleared. So basically, the longer you are playing the game, the more points you score per line clear. And there's a relatively simple formula here for doing that. Basically, the game here, or like the task, is to calculate what the game's final score would be, given that these were the sequences of line clears. So basically, your game was broken and it wasn't tracking your cumulative score as you were going. You cleared, so the example here would be like, you cleared 4 lines at once, then 1 line, then 2 lines at once, 4 lines, etc. And there's also a starting level, which is basically just a parameter to the point scoring function. So yeah, I think most of the rest of the rules and stuff are documented here. If you are interested in giving this a go, I also understand it's pretty late, so motivation is waning. But I do have a bunch of kind of limited edition merch with me from 50th anniversary and a bunch of other kind of Python-y related stuff. If you come show me any progress at all on this, you don't have to finish all of them. I mean, ideally you make a formula and so you would just be able to solve them all. But yeah, give it a go. If you have any questions or don't quite understand how it's doing the scoring, let me know. Or if you have any other general questions about anything that we've talked about today, yeah, we can do that. Is there any, in case folks, I don't really have much else after that, so we'll call it whenever you finish with that, we can be done. But yeah, thank you everybody for joining, and let's see, I'll set out some of the swag so you can see what I mean. Yeah.
So yeah, do the esports if you want, or if you just want to like try out some of the stuff we've done and just do a little simple thing. And if you run into errors, like we're right here, we can help you debug, so we got an hour, we can make it into a hackathon or whatever, like,
I will generalize it to work on anything.
yeah, we're here to answer your questions, so.
If you want the right.
Yeah, for context, I'm actually just asking Copilot if it can solve the Tetris thing. It's honestly gotten interestingly close. I have, like, so the things that I did were I literally just copied the prompt that's in the case here, asked it. Its initial answer, it kind of looped a little bit in that it was having trouble with the basically string of the number of lines cleared. There is an option on newer flights, like newer versions of Copilot, that has this advanced reasoning mode. It's like a little brain you can click here and toggle on. It makes your responses take a lot longer, but it does basically more back and forth between like its own personal review process before showing you. All I really know about it is it's the think deeply button. I don't know exactly how it's implemented. But once I toggled that on and asked it the same question, it actually, like, you can see this was its original plan. Parse the provided data, define the scoring rules, update the current level dynamically, calculate the score. It says there's a bonus, but I don't quite know what to do with that. And honestly, I came up with something that isn't terrible. I mean, that's a kind of a stretch, but I mean, like, it does actually write code that does follow exactly that plan. The names and verbosity are a little wild, but I'm still trying to find the error because I was just checking it. It doesn't get the right answer, so I'm trying to figure out where the bug is. But it also then offered, like, once it was finished, it was like, oh, I see there's some rows that don't, because it ran into the, like, empty row here and the bonus line and stuff. And they're like, it offered, oh, would you like me to exclude those from the analysis? So I said, sure, identify the outliers. And it's like, those ones don't belong here, so remove them. So now they're removed. So yeah, like I can say, redo your calculation with just the cleaned starting levels. So sometimes it's kind of a fun process to just follow along and see where it takes you. But I'm still trying to figure out what its actual bug is, because if anybody has an idea. So it turns everything into yeah, that seemed a little.
If you toggle over, then your lines bump, but then you should always score. You gotta-
Trying to think. Yeah, here's what. Yeah, I was going to ask it to try, because like, it looks like what this is taking, I was gonna A, ask it to add type annotations, and B, see if it would, rather than looping through in the calculate tetra score, just like turn that into a function that you call like mapped across the list and use like a generator to accumulate it. That might be too complicated for it. But I'm just at least asking for type annotations. Oh no. I don't think it interpreted type annotations correctly. It just printed out the code back at me with formatting, like markdown style formatting, but not actually updating my code cell, so. Anyway, you win some, you lose some.
Just for reference,
Mm-hmm.
what would it, do you know what the starting score is for the first game?
Oh,
It's on the analysis tab, it shows.
It's on, oh, the analysis tab.
oh, is it? I don't think the spreadsheet version you have has the answers, because I think I deleted that.
Oh, also, I'm having to open this up in LibreOffice, so.
Oh, yeah.
There are two examples right below the scoring thing. It's like example 1, example 2, that just has a sequence of like 4, 2, 2, 2, 2.
Yeah.
You
So,
could go like basically right around best cases for us. Just check the logic.
mm-hmm. But I do have the answers here, which when I first saw what Copilot came up with, I'm like, wow, that's kind of close, actually. They're like the right order of magnitude, but slightly off. But like almost constantly. Well, you could, I mean, if that works.
Okay,
Yeah, like.
It would be considered an anti-pattern, but in this case, like, each one is sort of different.
Take some stuff before you go, if you want. Please, I don't want to carry it back. And thank you for hanging out till the end. There's pins, stickers, socks, iron-on patches, clippy keychains. Okay, yeah, it's kind of, I think we're going down the crazy list, or crazy train now. I think I need to stop it. should you have the advanced analysis just kind of go off the rails, you can stop it. And you can, in the like hamburger menu, there's a chat history. I find even if I restart another one, sometimes it refers to things that it, like you talked about before, so I usually just go clear the whole chat history and then try again. Thank you so much for coming. Please take as much as you like. Take some for your friends, for your dog, who might also like spreadsheets, or cat. Mm-hmm. You got it?
This is fun. This would be so stressful to try to do in 30 minutes.
Oh, yeah.
Even like in Python.
That's true. Like, it seems typical that like because they have the World Championships every year in October in Las Vegas. Often the questions, if they do get solved in 10 to 15 minutes total. I don't remember.
What they're doing is break it out.
Yeah, I mean, mostly these are, like, they hold regional championships, and this was one of the, like, regional championships sort of questions, but, like, they have lots about games. There's also ones that are more businessy, that are, like, do a bunch of forecasting or whatever. Like, I picked the ones one that seemed most interesting amongst, and they have a big archive. So it's like, if you want to try out Kaggle-like problems, but without having all LLMs know what the problem and solution is, you might still be able to stump people, since I went through and, yeah, Copilot didn't, kind of just started going down a rabbit hole when I asked for type annotations. I think it got close, but yeah. I was putting up the answers in case you want to check what you got. Huh?
I think those are double. That's what I was getting originally.
These answers?
Yeah.
This is the answers from the organizers, yep. I didn't make these.
Okay.
I'll leave it up here. I can double check and re-download them, but I have not edited. I think it's one of those problems that I think it's much easier to state than to, like, because the thing I'm struggling with is, like, how do you, just like even the first task to me, which is figure out what level you're on before you then calculate the point scored.
Yeah, you have to, one thing where I was getting wrong was I was evaluating the level at how many lines you started when you got the score.
Yes.
As opposed to how many lines you were up after you got the score.
Yeah, so like.
Fix that was able to resolve some things.
Nice, yeah. Like, I feel like there has to be some mod 10ing, but like, I don't know. I don't know the right way to tell. You were in the back row. I wish I could have you screen share and we could talk about it. I'll come back there.
I got something that works pretty.
Oh, you do?
Pretty easily.
Awesome. I didn't want to change that number.
I could post it in Slack.
Oh yeah, sure. Yeah, unfortunately I don't have like a Python answer key. I just have the answers. Let me just pull up the Slack though. Which channel did you post it on?
The tutorial develop Pythonic spreadsheets.
Oh. Why don't I see?
Got browse channels.
You can tell how much I
Yeah.
use Slack.
I don't think people knew that there were tutorial Slack channels.
Yeah, I didn't. When I pulled it up, I looked and then I didn't see it, so I was like, but where do I browse?
Channels, browse.
Oh, okay. I thought it used to just pop up, okay. Thank you, thank you. Can I? Sure, join channel. So, add score, all right. Ooh, I like the lambda functions. Slick.
We basically need an accumulator.
Mm-hmm.
The lines and the scores.
Mm-hmm.
And then you have to,
For line clear and line clear results, so that's basically each number in that kind of big comma line. Okay. So that's saying, that's adding to the
yeah, so
accumulator.
You have to do the accumulation before you have the score, and then the way to select the level is using the
Ah, got it.
That's the double slash. That could also be like map floor.
Right, right, right. Okay, cool, yeah. And then now you've determined, now you've appropriately adjusted what level it's at, and then you can do the scoring, and add that to the score. Yo, that's slick. Wish I had an extra cool prize. Does that, if anyone was having trouble, does that make sense?
Yeah, I think I was zeroing out my score counter after instead of like doing the truncation.
Got it.
So if you only clear one line, that would work, but if you jump forward, then it's like, the counter for the next level should be starting at
Starting at 3.
3, yeah.
Three, yeah.
That's right. So like, there are two examples, like, it works, but they only ever like jump that first level.
Right, yeah.
So I think
Yeah. If it meets or exceeds the accumulation to the next level, that whole combo has to be scored at the higher level.
but it still counts, so
Yeah.
it's good.
Sweet. Yay, congratulations. It's a really, I think it's a pretty elegant solution here. Way better than whatever this nonsense is. Like, I find it does really like to make else if statements a lot. Like for things that should not. Yeah. Anyway. Come on. Let's see if I can get Python and Excel to run it.
And I ignored a lot of the setup and all that. So.
That's okay. I'm missing my Python button again. Oh, I did find a way to open this if the button goes away. If you right-click on any code cell, there is an open
I see show editor.
show editor. Yep. When in doubt, check the right-click menu. They clearly like to overload that like none other.
I think we're done, so we can
Yeah.